For your information, the camera covers up until the screen and the cable-ish.
Okay, so
if you want
I'm in.
Yes. I'm gonna add you to the stream. And we are live.
Perfect. Good morning, everyone, and thanks for joining me this early on a Friday morning. I know there's some issues with transportation to get in today, so glad you could all make it. As you might notice, I'm not originally a planned speaker, but still happy to be here. So I'll be talking about PowerShell and specifically pester testing and explain a little bit about that, and then go into some demos about what you can do with it in combination with Azure. So just to get a feel for the room, how many people have used Pester already? Okay, let's say about 20% would be my estimation. That's good. I have some introductory slides as well to talk about the basics, why we do it, the how, and yeah, let's make it an interactive session. If you have a question, just raise your hand and I'll get to you. Yeah, let's have some fun. So first of all, my name is Jaap, not a typical Swedish name. I'm from Amsterdam, where the event that was mentioned earlier is also held. So it's a great city if you can make it there. It's kind of like Stockholm, but with less islands. In my job, I'm a developer advocate, which allows me to be here today. So I work for a company called Harness. They do a lot of stuff with CI/CD, pipelines, software delivery, but we're not going to talk about any of that today. We're just going to have some fun with PowerShell, Pester, and Azure. I mean, that's my idea of fun. It might not be yours. So before I get into the meat of the presentation, the big why of why we would actually want to be testing anything. One of the reasons is writing documentation. Is that something that we like to do or we don't like to do? Because in my case, I definitely don't like to do it. Other thing I don't like is being wrong, and even worse, being wrong and having someone else point out that I'm wrong. That's something that I don't like. And also, I like the quality of my code or my Azure environment to be better than my initial setup. So those are some of the whys, but the real reason for me that convinced me to start using unit testing, operational testing, and just making use of the testing mindset is because I'm lazy, and I like to simplify things for myself. And initially, I thought it was challenging to do testing, but once I got a hang of it and saw some of the benefits, it made my job a lot easier. So with that, let's talk about what we'll cover today. So I'll talk about the tools that we'll need to get started with testing with Pester. I'll give a brief explanation about Pester, so you have an idea of what it is, what it can be used for. We'll talk about tests, writing tests. We'll talk about how this applies to Azure, go over some of the challenges, and then demos. How does that sound?
Great.
Excellent. Cool. So the tools, single slide. It's very easy. Obviously, we need PowerShell. Pester itself is a module that can be installed on PowerShell. PowerShell uses repositories like the PowerShell gallery. So if you want to have Pester installed, you do install-module Pester, and you have it on your system. If you're using Windows PowerShell, it's already installed, but you'll have an older version installed. I think version 4 something, and they're currently on version 5. The reason I mention that is because there is a difference in the syntax between Pester 4 and Pester 5, kind of like with Python between version 2 and version 3. And that is something to be aware of. And I'll point out some of the differences in this session as well. Other than that, favorite code editor, in my case, it's VS Code. I'll be using that for the demos as well. I have the package Pester test installed. I have the PowerShell package installed. Obviously, I also have the Azure modules, but just for Pester testing itself, these two packages are recommended. So let's talk a bit about Pester and what it is. So Pester is a behavior-driven testing framework. So what it means is you try to emulate what you expect to be the expected behavior of your code, your environment, and you build tests based on that. It's also a DSL, or a domain-specific language. So what that means is it's a sub-language within PowerShell. So it uses terminology that is not used in PowerShell itself. And that's something to be aware of. The first time you see some Pester code, and you try to just run it in PowerShell, it won't actually work because it doesn't know what those keywords are. And it runs on PowerShell. And when I say PowerShell, I mean both Windows PowerShell and the new PowerShell. That's open source. And well, as you can see, I'm running a MacBook, and new PowerShell just runs smoothly on that. Cool. So some of the benefits of using a testing framework like Pester. For PowerShell, it is the only testing framework that's available. For other languages, there's a lot of options, but it allows you to increase the quality of your code, and you can do that in numerous ways. But one of the things that I specifically appreciate about testing is the moment you commit code. If you're using a CI/CD pipeline or just a CI pipeline, you run tests the moment you commit. You can immediately see that whether the code you push is right, assuming you have the correct tests in place. It can help in part to document your code, because if you are writing tests, you're describing the expected behavior of your code. That can be helpful for other people that want to contribute, or often in my case, whenever I get back to my code weeks, months, years later, first thing I think is, who is the idiot that wrote this code? And yeah, that's never good to realize who that was. The second part is, how does it actually work? And tests both help with documentation, but also validating that the changes you made in your code are actually going to not break anything, or at least not anything that is covered by the test. And there have been cases where I pushed some code online. I worked very hard on it, spent 2 hours. I push it, the test failed. I thought, no, my code is perfect. Whoever wrote these tests is wrong. I was also the person who wrote the test. So I did the one thing you should never do when you change code. Either change code or change the test. Never do both, because then there's no value in what you're doing with the test. I did change the test. I just commented them out, and 2 weeks later I get a call from a customer, and they said exactly what my test said. The code was actually not valid. So it's a great protection mechanism against my own worst enemy, which is me. So it works really great for that. So I think I covered most of it. Mocking is something that we won't go in depth in today, but it allows you to, well, as the word says, it allows you to mock an output. So this can be used, for example, when your code is interacting with web services. You can mock the output that comes out of there instead of actually reaching out to an external endpoint. So you can validate that your code will run. The challenge of mocking is not mocking too much, because if you mock your entire code, then the test will always pass, which is great. But so some of the challenges that we have when writing tests is, first of all, that you'll need to have code that is actually testable. And what it means is that when you're writing your code, keep in mind that at some point you might want to test it. So if, for example, you're using environment variables that you have no control over in the testing process, and you're using that to validate things in your code, that you will never be able to test what happens if there's a different environment variable, if it's something that you can't set. So what you could do in those kind of cases is to write a helper function, and you could mock that helper function in order to be able to test your code. Also, determining what to test is something that's important because there are a lot of options of what to test, and some things make more sense than others. Then it gets to writing tests and actually validating that the tests are working as expected. So the other part is, this is mostly if you're working on projects with others, which is something that I increasingly do, is to have some kind of guidelines for contributing to a project. So this can be your colleagues, or if you're hosting your code online on GitHub and you're open to contributions, having some kind of guidelines and minimal viable code for it to be allowed into the repository is something that's hugely beneficial. So then we get to things that we can actually test, and this is not PowerShell specific, but these are some of the issues that I've run into. Is when you're running tests, you can get different output on different operating systems. For example, if I try to open a registry key on my MacBook, it will obviously fail because there is no registry there. The PowerShell versions themselves also have some different behavior. Some of the commandlets were suboptimal in the past, and they're better now. So keeping those things in mind, it can get quite hard to have the full picture because that takes a lot of time to understand. But having that understanding of the differences in versions, you can run your tester test on all different operating systems with different versions of PowerShell to validate that it will work as expected. And that is something that's very easy to do with CI tools. So if you're using, it doesn't really matter which platform you use, if it's GitHub Actions or Azure DevOps or Harness, you can just pick your operating system, pick an image there with a specific version of PowerShell, run them all in parallel, and you can test against 5, 10, or however many versions you want to test against. Other part is web requests. Already touched on that. Those are the kind of things that you want to mock. .NET versions is something that was more of a problem in earlier versions of PowerShell. So still in the Windows Server times, if you installed a service pack on Windows Server, you would get an updated version of .NET, which would add functionality that would not be available in unupdated systems, and you can run into issues with that. So that's something to also be aware of. And then also the tooling version. So if you're using any kind of external tooling, making sure that you're aware that there can be differences with different versions. Any questions so far? Does it all make sense? So let's go to some of the examples of unexpected behavior. So I'll go over a couple of examples in screenshots, and later on we'll dive into some actual demos of code. So in this case, I get into the issue with an older version of PowerShell, Windows PowerShell, where Unicode was not working as expected. So these are actual tester tests. So how it works is we make a statement, we say it, so we put a description in here, the string parameter, string should return true. So in this case, we have some Japanese characters, and we want to validate that this is indeed Unicode. So these tests were useful because what I ran into was when you're using modern versions of PowerShell, it would correctly expect Unicode. If you were using Windows PowerShell, it would just create it into blank ASCII characters, which was not very useful. And it was actually a Swedish company that reached out to me to have this fixed because they used all the funky characters that you call normal characters for their database names, and my code didn't understand that well. And the code itself is fairly simple. It's just a regex string to validate that it's outside of the range of the normal ASCII characters. And the eventual workaround is that instead of just doing a web request, I had to do this in order to get the Unicode out of PowerShell 5. So make sure you run the latest version of PowerShell whenever you have the chance or you have the control over the system. Neat thing to know, you don't actually need admin permissions on your system in order to be able to install the latest version of PowerShell, because you can just extract the zip file in your My Documents and run it from there. But don't tell anyone I told you that. Documentation is also something that that I like to have tests for. So the reason I made these tests is also because someone made an oopsie. We're not going to name names, but it was definitely not me. With
4 months.
Well, it was definitely me.
Oh.
A challenge I ran into, PowerShell has this neat thing where you can have comment-based help. You can extract this comment-based help, and you can generate HTML files or Markdown files, and you can host those on GitHub, and you have nice online documentation of everything. I found out the hard way as a solid Windows engineer. Capitalization never matters. Well, with web servers, it does matter. So I came up with a test to just make sure I would never enter capitalized links anymore. And I would make sure that the path was also correct, because I also messed that up a couple of times. That's just dirty copy pasting and just making sure that I don't run into that issue again. So that's part of the development process for me as well. Whenever I run into an issue or I see myself make a dumb mistake or a smart mistake, I just write a test for it just to prevent myself from running into that same issue again. So the problem with writing tests is that you can, depending on how many tests you write, how much code you have, you can end up with 10 times as much code in which you define your test than having actual code. So having the right balance there is important. Gets back to knowing what you want to test in order to be able to test the functionality. Also knowing what kind of tests to write, because you can write unit tests. Unit tests you use to just test a fraction of your code to see if it works as expected. You can do integration tests where you just run your script or your code. You check if the result is what you expect it to be. And one of the tricks that I've used to make it easier for myself and for others is to have some kind of scaffolding in place. And what I mean by that is either have an example test file that you can just copy paste, rename, and start writing the test for whatever changes you make, or if you add new functionality, put those tests in there. Or automatically generate tests if you are mature enough to be able to do that. But that once again ties back to how mature is your development process. Other thing, another challenge with tester tests is if you have a big project that you're working on. I ended up with a project where where I had 1,700 tests. And the way I organized the test was just for every function, I created a different tester file, a different script file. So it would go over each of those files, 1,700 of them, and every time it would import the module and import the module in the next one. And if you do that once, it's a couple of milliseconds. If you do it 1,700 times, it's a couple of minutes. So it ended up taking a lot of time. So the way I solved that one was initially I was thinking of parallelizing it and just splitting up the tests in batches of 100. It was faster, but it wasn't that much faster. Eventually, the solution I ended up going for was taking all those separate files and merging them into a single file. So there was only one import necessary, and then it ran in practically no time. I think it was about 20 times as fast. It was less than a minute. Because that is one of the challenges. When you write code, you immediately want to know if your code is going to be functional. So you don't want to wait 5 minutes, because if I don't have anything to do for 5 minutes, I'll just open up YouTube and watch some videos, and then I completely forgot where I am, and it's 5 hours later, and I'm ready to go home. So optimizing performance is something that is important to keep it usable. So I mentioned the parallelization. Find a way that works for you. In my case, the way I split up the different jobs is to split it up by either PowerShell version, or if you're writing for multiple operating systems, split it up per operating system and then per PowerShell version. So I usually end up with somewhere in the single digits of concurrent tasks running in my CI pipeline. So that was a lot of code. Let's talk a bit about what we can do in the Azure world and what we can use this for. And after that, I'll give some examples of how you can use it and how we can make creating the tests themselves easier. So there's a lot of things to test in Azure. A logical one is Azure Functions. Azure Functions can also be given in PowerShell, so you could just test your code there. It's just testing PowerShell code, so that is a relatively simple approach. Logic apps is another one. Your infra as code, you could be testing your ARM templates. The other side of things is testing your Azure resources. If you have a known good state, you can also use Tester to run operational tests. And I know some colleagues of mine, they build large lab environments, and they have fantastic Terraform and Ansible templates for that to be able to deploy everything. But they had no way to actually do the final validation aside from using Terraform validate or to see if it's actually built as intended. So they ended up with a scenario where whenever they built the lab, they would run an entire test suite of tester tests, many of them automatically generated, to be able to validate that every student's system would be exactly configured the way it was. So that's another approach. Instead of testing your code, is testing what is in production and what is operational. So that's also what I'll go over in the demo. And then the most important thing, and also tying back to the fact that I'm self-admitted very lazy, is to don't write tests. So let's look into a future where we no longer have to write tests, and let's also get a reality check of it not being as rosy as we want it to be. So I think we're all familiar with the natural language models. In this case, I asked it to for a very simple PowerShell function, can you generate some tester unit tests? Unfortunately, I was not very specific, so I just told it to generate tester unit tests. So it came back with this. So these are valid unit tests, but they're only valid unit tests on tester 4, because this block right here should be inside the describe block, because otherwise it is outside of the context. So all the code that you write outside of this block doesn't work for this. So the function would not even be available and all the tests would fail. Second mistake it made is that it didn't take into account that if you would run this test, your pester test would actually stop at the first test, because it's testing if a parameter is there, but the parameter is a mandatory parameter. So the console will just wait for you to input that parameter. So these are not very functional tests. So the future might be there with some things, but it definitely requires a bit of hand-holding to get it to a good state. And here is the context of that Stack Overflow from Matthias. You should not do tests for mandatory parameters. So there was a lot of talking from me. Do you have any questions at the moment before we get into some actual pester tests? Cool. Let's make this one bigger. Is this big enough for the people in the back? Excellent. So the function I showed in the screenshots as well, it just adds two numbers together. I'll show the output. I'll first load the function in memory, and I'll do add number. Can I get two numbers from the audience?
Two.
13. And what's the answer?
I don't know. 42.
15. Fantastic. You were almost there, so close. Okay, so that seems to be working, but we are actually going to go for some of the test to test app, and if we want to do that, we'll do just invoke tester, and it should be in the right folder. So if we take a look here, we can see that we have add number and we have add number tests here. So if we run invoke tester, it will just look for all the tests that are in this folder. We could make it go recursively, but we don't want to do this because I want to do one test at a time. So we can see that, oh, it actually does it recursively. We can see that the tests have failed for this one because it expects the output type to be int64. So it's expecting a longer integer rather than the short one that's here. So if we take a look at the test itself, you can see that it's testing for int64. And then one of the things that this one. It doesn't come up anymore. No, thank you. So then what we'll do is I built a small wrapper for tester because I like to make my life easier. I've already shown that GPT wasn't very good with generating the test. It tried really hard, but it's a little bit dumb. But if you do the appropriate amount of hand-holding and you're precise enough, you can actually get decent results from it. So that is what we'll do here. So get that one loaded. So I'll clear this one out. We'll run the tester test again. So we have invoke tester. So you can see the test fails. And now with invoke tester GPT. So that's just a wrapper. It doesn't do anything except display a fancy logo if the tests actually pass. But if it doesn't pass, it will take the failed test. So it will take the definition of the test itself. I created a prompt for it to come up with a solution. So it comes up with two solutions. Let's see if I did it correctly. So it comes up with two solutions. One solution is fix the unit test. The second solution is fix the code. It is actually a correct solution. So I want to hear from you. Which one do you want me to do? Fix the code or fix the test?
Fix the code.
Fix the code? We'll fix the code.
Like you said.
Only ever fix one thing at the same time.
Yes, because you define the functionality using the test, so you don't rewrite the test to get the code.
So there we go. We change it into long, or well, it is actually looking for N64. So here. And then we run the test again. And we can see all the tests pass, and it no longer comes for the GPT solution. So that was the tester way of testing our code. For the next one, we're going to test something in Azure. So let's switch over to the browser. So what I've created is an Azure key vault. I put some secrets in there that we can test against. And we just want to validate that this is deployed exactly the way we initially deployed it. So in order to do that, we created some operational tests. And these are tests that will actually look at the Azure environment and take a look at what is happening there. So go over the code for that. Let's close this one. Let me see. Yep. So you can see here we are going to assume that we're already connected to Azure. So if you're running in a pipeline, in an Azure DevOps pipeline, make sure that you're logged into the right account and you're using the right credentials so you can actually verify these things. So we're going to validate a couple of things. We're going to validate that it exists. It should be in the correct location, West Europe. We want the resource group name to be as expected. And we're going to check for two of the tags. So let's see how we go with that. Going to Azure demo. Invoke regular tester. And of course, tests are no fun if they if they run successfully, or well, it is fun when you're running, when you're doing your job, but for demos, we want things to fail because then we can take a look. So you can see it will give us the context. It will tell us, all right, it was expected to be medium, but it is high, so it didn't get the expected result there. So then, once again, I'm lazy. I don't want to come up with a solution. So what we do is we'll just get the GPT answer again and see if it can come up with a solution that is easy to implement for us. So we do invoke GPT. So we can see it comes up with the error. It will go with a prompt. So what I prompted it with is, I have an Azure resource, I'm running an operational test against it, and I want you to come up with a solution. And when I tested this before, it totally worked. So let's see if it actually works right now. So let's see. It's not behaving very good with fixing the unit tests. So it doesn't fix the unit test correctly, but what we can see is it does actually tell us which command we can run against our environment to immediately resolve it. So if the test says it should be medium, we can now run this and set it to medium. And if we wanted to, we could also have it executed for us, but let's not go that far. Let's not give AI control of our Azure environment just yet. But let's see if the code is actually successful. Let's see.
You missed the first one.
Did I? Right. default name. I like to copy paste things because then I can't make mistakes. I mean, I make less mistakes if I copy paste things. There we go. And then reset. Well, it didn't come up with a functional piece of PowerShell code, so that's unfortunate. The nice thing about it is that we still have a job. The downside of it is that the PowerShell commands it generates, you should still treat it as a very enthusiastic, agreeable intern that will tell you whatever you want to hear. It will sound very believable, but put some question marks there. But at least it's pointing us in the right direction. It's telling us, all right, so apparently I need to change the priority back. The PowerShell code was not functional. Good. Let's put it to medium and then see what we get back. Here we go. So running the tests again, and all the tests pass, and our environment is healthy again. Oh, no presentation. There we go. So, what I hope you take away from this is there is value in testing, both testing your code, but also doing operational testing to be able to validate that everything is exactly as you expect it to be. So this can be useful in many scenarios. I gave the example of when you're building a lab environment, but it can also be a sanity check for yourself before starting a migration, or a manual morning check that just can be replaced by a series of tester tests. And whenever you get results back, you know that you're in a known good state. There is value in testing. There's not a lot of value in writing tests. So if you can find a way to make it easier for yourself, either by using scaffolding, automatically generating, or dealing with large language models that sometimes give you results that work. And with that, I'd like to open it up to questions. Yes.
If no one else has a question, I'll ask a question.
Yeah.
So when I run tests in Azure DevOps, especially around things like APIs, I get a nice little report because I use things like NUnit or JUnit in order to. So if I were to incorporate this, do I get a nice little report of that's, I would say, human readable, or at least release manager readable, if you know what I mean?
I'm not exactly sure what an NUnit report looks like, but you can choose
basically the names of the tests and whether it passed or not.
Oh,
if it didn't
yes,
pass,
yes.
then basically why did it pass? So kind of what you've been getting down there.
So what we're seeing here is if the tests are successful, it doesn't display anything, but we can change the output where it will display all tests, and it will give you output back how many milliseconds it took and whether they were successful or passed. In this case, it doesn't display it because the default output is to only show errors in the console. But you can make it output in multiple different formats. If we go invoke tester, check. We have something called output format, and then we can choose between JUnit, NUnit, XML.
That's what I was looking for.
You have to add -CI as well to make it output. -CI. That's the one that outputs the actual test result.
Okay, cool. Thank you. Cool. Well, in that case, I'd like to hand it over to the next speaker. Thank you very much, and have a nice morning.
Awesome.
Good, no, great.
switch myself off.
Your computer. Good stuff.
Woke everyone up.
Now my mic is off on my computer, I think.
Mm.
We hear lovely Lenovo. Yeah, that's what I thought.
I'm good.
Okay. Shouldn't you do that music thing first?
No, it's on one stream now.
Okay, good.
Yeah.
No music. No problem whatsoever. I hope you guys online really appreciate the things we go through in order to make this thing happen. Hi, I'm Michael. I need to speak to you about 10 ways of making your API super secure. And I really would like this thing to start messing with me. I'm an integration and Azure architect at Permoville. This is me. This is what I do when I'm not here. I've been working in IT since 2001 now. I do integration mostly, and I've been working with integration since 2003. I was in Azure as early as 2009, actually. My account is fairly early. It wasn't even available, you couldn't even get virtual servers back then. I've been working with Azure professionally since 2016. I have a Twitter account. I have a blog, if we still use that word for it. And also I have a GitHub page, and that GitHub page might become useful to you down the line. I work for a company called Permoville. And yes, it's that Permoville, which you know and love, of course. And we do have an IT department, actually. We're mostly famous for our powered wheelshares, which are, of course, the best powered wheelshares in the entire world. But we also do things like manual wheelshares. This is the so-called Tylite. It's a titanium alloy thing. It's super strong, it's super light, it's super usable for people that have to use wheelshares. But we also have other things, such as the Smart Drive or Power Assist Drive, which is basically putting an electric motor on top of an existing, in this case, Tylite wheelshare, and it will help you along the way of your day when you're getting tired, basically. People in wheelchairs tend to sit down even more than people that work in IT, of course. So therefore, we also have all kinds of cushioning and positioning products and making sure that the people that use our product have as good a day as possible. Permoville used to be a Swedish company, and we're still a Swedish company, but we're not a small company. We sell in over 70 countries. We directly sell in 18. We have 1,800 employees worldwide, and we distribute, according to this slide, about 1 million products yearly. So I work for a fairly large enterprise organization. I've always worked with fairly large enterprise organizations, and I will talk about this API thing as if I'm in an enterprise thing. If you are within a company that sells like API data, this might not be 100% up your alley, but I will present this as if you all guys were like enterprise dudes, much like myself. So let's start off with defining the basics. Like, what is an API platform, and why do we need a thing like a manager? This is the most basic API I could think about. You have some kind of external user or service of data that calls some code, in this particular case, an Azure function, which exposes data in a database, so an SQL server or something like that. But this thing kind of quickly, within the enterprise landscape, becomes quite complex, because you get a lot of different functions do a lot of different things. And you have things like Azure Functions and Logic Apps running side by side, perhaps exposing kind of the same data. And they all have different ways of authenticating and different users and all kinds of things like that. And it kind of quickly gets out of hand, and you stop reusability of your APIs. So if you're only like running on that, you might not need an API manager, but if you're running in a larger enterprise and have this thing, you definitely would then need an API manager. So that's the symbol for API manager in Azure. You usually tend to think about APIs in layers. So on the top, you have like the user layer. This is where the person who's using your API resides. Then you have what's called usually an experience layer, which is basically how the API is exposed to the world. Then you have a process layer. This is where I would say your code runs, basically. This is where your actual functions reside. And then you have a system API, which is then either the database in the backend or another third-party API, much like the ChatGPT we were looking at earlier. And by the way, this contains no AI whatsoever, so don't get hopes up. I will be speaking a lot about this layer today, and I will be speaking very much about this thing, the security part of the experience layer. The typical API call then looks like this. Some caller calls your API manager. The API manager looks at whatever it needs to look at, such as an API key. Are you authenticated? Can you access this thing? If you can, I will forward that call to my backend service, in this case, an Azure function, who calls the database and then just send back, user data over it. I will do a couple of demo calls today. This is the thing that I set up. I will use Postman to call, again, API manager. And that API manager calls a custom function that I built on top of an API from Trafikverket, which exposes train departure times from Central Station. Everyone loves trains, don't they? But you can't talk about security without talking things like hacking. And you also need to do one of two things when you speak about security. The first thing you can do is to try to pull out an old anecdote about a stupid sysop who had the administration password right here on a post-it note all day or under the keyboard or whatever. And we can all go like, ha 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 ha, that's so funny. He was so stupid. But that doesn't help us. So I don't do that. What I do instead is try to scare you and say, this thing exists. And one thing to do is to put up this guy, the hooded fellow that's hacking your thing. If you Google hacker, that's the thing that pulls up, basically. So that's why it's here. Here are some examples, and I'm not expecting you guys at the back to be able to read what's on the screen right now. In fact, you should probably benefit from moving a bit forward for later demos. But let's look at the thing that's called Python exploits grabs 10,000 API keys. That was someone who programmed a Python script to go into the Wayback Machine and try to pull all kinds of different APIs that the Wayback Machine just had archived. And it could pull up all kinds of stuff from configuration files. Why are you storing your API keys in clear text in configuration files? Well, that's what it did. A more recent thing, kind of not recent, is what's called the remote time attack, which is basically down to how the underlying code works. If you send in an API key and it responds back very quickly, you as a hacker know that this key is very, very wrong. So you could try another one. And if that response time is shorter, you know you're getting closer to the truth. Kind of like that old game Mastermind, if you kind of remember. But me personally don't see that as a big threat, because things like lag in the network and such kind of mitigates those changes. So let's go into the top 10. And the top 10 here is presented not from 10 to 1, which is kind of the usual one. And it's presented from 1 to 10. And it's also presented in the level of easiest to kind of being more advanced at the end. Who here runs APIs or API Manager in Azure today? Raise a hand. Yes, a lot of you. Awesome. Good, good. Because I'm going to be kind of advanced towards the end, where I realize that some of you might be beginners, but I'm going to start at the beginning. So if you already know this, just rest your head for a while, and I'll get back to you from 5 or so. Number 1, use the API key. For God's sake, of course, protect your API. That's the first thing. Use the API key. Why do I say this? Well, because I found APIs that haven't used any API key whatsoever. The API key is also used within the API manager to get all kinds of statistics about your caller. So therefore, make sure your user uses an API key as individual as possible as well. Manage your products. So within the API manager, you organize your APIs into groups. These groups are called products. The original thought about this is that if you have APIs around trades, you put that in a product called trades, and you have APIs about employees, you put that in a product called employees, and therefore you have some kind of order within your APIs. Because if you have 200, it's kind of hard to follow them. I do the opposite. I group APIs based on who's calling these APIs. Calling systems. So I might have a calling system which needs HR data, and that system is called, I don't know, HR1. I will then create a product called HR1, put all the APIs that system needs in that product. That product then generates a subscription key, so that system can only access things that they are supposed to. They can't even see the other APIs. Once again, going back to enterprise, I want to keep things as low end as possible. I'm not promoting my APIs. Update your global policy. This thing is in every API management, and it's very rarely touched. Every call that comes into API management passes through the global policy. And you can do a couple of nice things using global policy to stop or mitigate issues. This is not mine in production, but it's very like mine in production. And just looking at the code here, if you're not familiar with API management, this is the coding language or configuration language of API management. The only thing you need to know is it kind of looks like XML, and it's also, I think it's called procedural. So it starts at the top and just works its way down. It doesn't go up again. So there's no looping in this, right? So therefore, if it says a condition of, hey, can I find something called subscription key in the query string? Then return the response, and then it will not come all the way down here, right? So because it's procedural. And what I do is that I keep people from putting the API key as a query string, because that's not as secure as putting it as a header, which is what you usually do. The name OCP API subscription key is the default name for a subscription key in API management. And if it says, what it says here is that delete this key when you encounter it. Because if you don't, API Manager will gladly just send that key to the backend system, and you have then exposed an API key. Because, I mean, who is that backend system? So make sure you always delete that. Feeling a bit stressed today. I'm gonna, slow down a bit. Last time I did this talk, it was 1 hour and 10 minutes, and I have 45. So I skip a bit at the end, I think. Number 4, add alerts to your system. So why do you want to add alerts? Well, if something bad happens, you want to know about it, right? Because you have your wonderful API here, and then suddenly this guy shows up, and everyone knows that this guy is up to no good. So he starts poking your system in order to find some kind of information. And it will then respond back with authentication codes like 401 and 403. Why not put an alert there to just say, hey, something happened. Something bad might be happening to your system. What's an alert? Well, it's a native thing in Azure. An alert is always connected to an action group. What is an action group? Well, it's a group of actions. If this alert happens, execute these actions within this group, such as send an email to the admin guy, or start a logic app to do all kinds of things with that's close down the system, revert a subscription key or whatever. And I've tried so hard to find a good and cool way to illustrate alerts, but I couldn't. So I'll just have to do 2 slides instead. These are 2 of my things that I run. And let's look at the second one first. So very very, very small print for guys in the back. But it says requests bigger than 5. So this is a static thing. It says, this one basically says, if I'm returning more than 5 statuses called 421, which means I'm throttling within a set time. In my case, it's 5 minutes. I might be having an issue, or rather, my backend system might be having issues. So if I'm feeding back 429, which means I have too much to do, I'm choking, can you please back off? That's what 429 means. I might have an issue, so I want to know about it. The other one is called a dynamic threshold. And it basically says, if you receive more 401s and 403s than usual, send me an email about it. And that for usual, kind of machine learning kind of thing for itself. And just, well, you usually have like 5 an hour, but now we have 20 within 5 minutes. There might be an issue. And this has actually helped me in my current thing, where a project started up an old test machine, which had an outdated subscription key and started pulling an API for more information. And yes, I got an error about it, and I could tell them that guys could basically back off. As I like, or rather love, Bicep, I think it's here, yeah, it says Bicep. I can also tell you that these things are highly scriptable with Bicep. So you can just deploy that as a part of your platform script. Now it's time to wake up if you already do API management. Let's get into the hard stuff. Start using the application gateway. So where does the application gateway reside? Here's a typical API call again. The application gateway resides here, in front of your API management. What is the application gateway? Well, it's Azure native. And that might be, superfluous information, but I've been told that I should point out when something is Azure native, because that basically means you don't need to download third-party apps and store them on a virtual machine that you need to maintain. You just provision it and it's there. So it's an Azure service. It's a service-based gateway. A gateway means come in through here as a gate. There might be guards and so on and so forth, which we'll be looking at. It has a simple load balancing. So if you're using this in front of one API management instance, might not be that interesting, but you can actually use it in front of, let's say, 10 Azure functions, which are basically running the same thing. It can then round robin the calls to your 10 functions in what's called a backend pool. And you can also make this a part of whatever company you're working for by installing a certificate on top of it. So it becomes your actual gateway into your company. I could make my gateway look like it's a permobil.com gateway, which could, be very useful for people calling. Instead of having that typical, this is obviously an Azure service thing that we get. So I really hope that things will work well with the stream now. And if it doesn't, I really don't know what to do. That's the way you stop it. Because now I need to go into duplication mode. So I really hope everything will work. That was cute. There we go. But never mind.
I'm looking at it.
Okay,
Looks
good. Awesome. This is the application gateway in Azure. I have zoomed in as much as I can. It doesn't look as much, but you can see that it's actually native. What you get is, of course, some base statistics, like how are people using this gateway, which information is going through it, number of fail requests. You could look at things like that if you want to. In order to set this thing up, you need to configure a couple of things. And the first thing you need is, of course, a front-end IP address. So we need to reserve an IPv4 address, and that will then, point to your gateway, basically. Then you need to add what's called a listener. And the listener is basically saying, if someone calls me on this port, activate this listener. It's just like an ear on the internet, like looking for this. Is someone calling me? So I set up a listener here. It's on port 80. You can set it up for 443, but I didn't have any good certificates just lying around, so it's in port 80. So it's unencrypted. That's basically what I'm saying. When you configure that, you can also see that it's called what's called an associated rule. So the listener, the listener awakens and then it activates the rule. What's the rule? And now we're really getting into the funny layout parts of Azure. It's actually quite good. So if the listener has a backend target, I have said that the backend target is my API management thing, of course, but I also have two what's called routing rules. And if we look at this routing rule first, let's see if I can scroll even further for guys at the back. It basically says if the path contains any of these patterns, activate this rule. So this says if someone calls this API endpoint with /train/v3, then whatever, send that to the API management thing. Okay, why is this good? Well, the reason is very clearly because there's another rule, which is the default rule, which is called a sink rule. Why a sink? Well, a kitchen sink. You put all kinds of crazy stuff in your kitchen sink that you don't want to, put on the table or whatever, especially in the Americas. They have that thing on them. This means that if someone just tries to poke your endpoints and just look for whatever, they don't even get a response of 502 back, which basically means, gateway error. They don't get any kind of information about your APIs behind that thing, unless they specifically know that they should put /train/v3, then whatever. Then that will respond back. So this is a very, very powerful and easy out-of-the-box thing to do. Back to the slides. Nope, that's not it. That's where did I start the presentation? Here we go. Once again, looking over it, the screen is looking okay. Yes, awesome. Very, very nice. Next thing, this I dread actually to tell you guys about because it's networking. I'm not a network guy. You will very, very, very clearly find out if I present this to you, especially if you are a network person, right? But I will try anyway. Here's your typical API call again with the gateway. Where do you put your network thing? You can put it here in front of your API management. Why is this so cool? Well, let me preface things first. When up until like a year ago, the only way you could get network connectivity for API management thing, make that part of your network, was to buy the not that affordable taste. It's called the premium version. And I don't remember exactly what it costs per month now, but it's like 30,000 or something compared to the lower tier, which is like 5,000. So it was that kind of thing only because you wanted the network stuff. But now we can have the network stuff with the lower tier things as well, using what's called a private endpoint connection, which is finally supported by API management. It's an Azure native service, which is a service-based network gateway. Now I'm just reading off the slides, because I'm not a network guy, but it has support in that. And you can make then your API management part of any of your API management, any of your networks within Azure, which is kind of awesome. It's supported on all SKUs except for the consumption SKU. If you're using that, sorry. But that means instead of 30,000, at least 2,000 or something per month, which is awesome. And one API instance can support up to 100 endpoints, which means it can present itself as a local resource within 100 different networks within your company, which is kind of beneficial, I would say. So from a non-network person's view, this is how you set up an API endpoint, a private endpoint. You start off by creating a network. Duh. And then you create two subnets within that network. You put your API management, you put your gateway in one of the subnets because it needs an entire subnet just to function. And then you put your network, your private endpoint in that other thing. And that's connected to what's called a DNS zone, or a private DNS zone even. So that means very, I'm gonna go over here now. If someone comes through here and asks for this resource, this one will look at the DNS zone for the local private DNS zone and say, oh, I will use this one in order to access the service here. You can still access your API management from the web if you want to. You can turn that off using like some PowerShell script or whatever, but that's the way you do it and how you expose this thing. And I'm going to try to show you how to do this. So let's start off by showing how this looks in API management. That's not it. This is more it, I think. Within API management, there is something down here called network, which is now finally available to us sheepo guys, and we have what's called an inbound private endpoint connection. Wonderful. And I've created one here, and you can see I can still add more, so up to 100. This demo endpoint is a private endpoint, so now we have left API management. And it contains a couple of things. It's connected to a subnet, you can see that here, but it also has a network interface. And if you're an older guy like me, network interface is like the network card in your computer, or a way for the network to actually connect into it. And if you have that, it's the same thing as running the thing on a network card. And looking at the DNS configuration, I'll not jump deeply into this because I don't know it. But it basically says that if someone uses this fully qualified domain name, integration, blah, 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 use this local IP address, which is exposed on this network interface. And that's the way how your thing can then, go through a private endpoint, or rather a private or local IP address. Looking at this from the standpoint of your API management stuff, I am going to do, sorry. Okay, let's do like this. So here's my API management. I have two different operations. I have one called get departure and one called get departure internal. If you look at the get departure internal and look at the code for it, I will zoom in, no problem whatsoever. I'll just, there we go. Let's look at this row basically, row number 6. This is what we do. We say, as a software developer, I can say, in the request, is there a private endpoint connection object? And if it isn't, I will send back that that's a bad request and say, this operation is for internal use only. So now people that have not accessed this API through the network can't access that information. And then I say, if the private endpoint name is demo endpoint, my endpoints, I will then route you to the backend thing, get that trade data that you really, really, really want. So that's not that hard. Let's look at it from a standpoint of Postman. So let's go with get traffic info internal. So I have not pre-cooked this because it was a bit of a time thing. So if I send this request and wait for those wonderful seconds on stage, which seems like hours before your demo actually works, it says this operation is for internal use only. Why is that? Well, because I accessed this directly. So this API base path points directly to API management. It doesn't point to the network. How do I access the network? Well, I go through the gateway, which I established, right? Or rather, which I created. So you can see that it's another. It says API security demo, which is awesome that existed instead. And if I send that over here, it will still take those wonderful year-like seconds before I get the response back from like which train is bound to depart from the central station. If you're going home today, you could use this. No, of course not. So now you get that back, and the reason is I'm calling it through the gateway. Whew, that was a journey. Fairly quickly going to jump back into my presentation. Just one slide, I think, before that's new demo time. There we go, and boom. Yay. Number 7, use a firewall. Why not use a firewall? Well, where's the firewall? There's the firewall. That's the typical API call. What is the firewall? Well, it's a web application firewall, or colloquially called the WAF, because it sounds funny. It's connected to the application gateway. You can connect this WAF service to other things as well, other types of gateways, like the Azure Front Door, but I'm using it for my gateway. Like I said, you could use other services. It has a very, very simple management. Like I said, I'm not a network person. Do you think I'm a firewall person? No, I'm not a firewall person, but I feel confident I can have this and guarantee a certain level of service. It supports logging via Azure Monitor, and you can also do simple things like validate incoming messages. If this is turned on and your caller says content type equals application/JSON, it will say, let me take a look at that JSON message just for you. It will not validate it towards a schema, but it will look at the format. And if the format is incorrect, it will be rejected. I will show this in a demo. And you can support what's called the OWASP rules. Here's the only thing you need to make sure if you're going I need to try this on Monday. If you're going to set up a WAF for your company, make sure you use the OWASP rules 3.2. That's very important because then you can use the new, cool, bigger, better version of that. That's the only place you do that. What is OWASP? It's the Open Web Application Security Project, non-profit kind of thing. It's open source. They had earlier published a famous top 10 thing in which they rate those kind of threats that is out there to APIs. And then they, in this particular case, they just compared 2017 to 2021. So that's the latest release, basically, of it. The really good thing about this is that these people are firewall people. They know this shit. They work very hard. Sorry, I'm not the other word. They work very hard at making sure that this thing works. And the only thing I need to do is say, yeah, let me use it. So let's take a very quick look at how the firewall thing is set up. There we go. There we go. Let's go to here. Oh, that's not it. Let's go into there. Nope. Where did I put it? There's the firewall. And I'm going to use that one. This is the firewall, which is it's connected to that routing rule I was talking about earlier. So it's only executed when someone tries to call those APIs, because you can have other things connected to your application gateway, right? So here are the policy settings. Inspect message body. That's the thing I was talking about earlier. And the only thing I did was say, yeah, I want to use that. And then it said, how many kilobytes do you want support? 2,000 is maximum. So of course, I want everything I can get. So 2,000, and that's it. But then we also look at what's called the managed rules. And if I click the thing, I will be able to show it to you. There we go. Now, the layout and so on and so forth. But here are the rules, which are now supported by me sliding something to the right. These are, a couple of things which people think are fairly important that you can have a look at. Things like SQL injection attacks, or the famous little Johnny Tables SQL injection thing. Which is awesome, because someone who's much better at this kind of stuff just said, well, implement these rules. And I go, yes, and we're secure. I think that's awesome. And what you also can do is that that you want to say method is not allowed by policy. You could just go like, nope, I don't want that. So I disable that specific rule. There might be reasons for it. You could do things like exclusions as well, like saying, well, unless this thing happens. So I have had issues with the firewall looking at the authentication header and looking at that bearer token, which people who have used a lot know what I'm talking about. And it looked at that and said, this is gibberish data. I will reject this thing. So I basically said, implement everything unless, don't look at that authentication header, you leave that alone. So that's it. you can set up things like custom rules if you want to, but I don't want to. But you could look into that, and it's connected to an application gateway. And firewalls are super easy. So, I mean, start using it. And let's head back again for a couple of slides. How am I doing on time, by the way? Is no one?
25 minutes.
Oh, Jesus! I will skip through a couple of things then. Utilize logs. I had a log demo prepared. I was so funny, so I'm not going to do that. Of course, where is your logs? Well, your logs is separate things. It's out here. It's something called application insights or Azure Monitor or logs, which then, you connect that to your gateway, to your gateway. You can get all kinds of information on what's happening within your gateway, which firewall rules have been fired and why, and so on and so forth. So start looking at that. Let's start instead, just skip that and go into the OAuth thing, which is also kind of advanced. Who in here has implemented OAuth on top of anything? Yes, a couple of you. Who here did that the first time and said, well, that was easy? And no one did that or whatever. It's OAuth. It's like a lot of GUIDs and client IDs, but I'm not going to dwell into that at all. I'm going to just present the process to you all of what OAuth is and why that's very useful for APIs. This is the process. You have a caller. That caller wants to talk to your API. That API is protected by OAuth, and my OAuth provider is Azure AD. It has a built-in thing for it, so I'm going to use that. Once again, enterprise. So it goes to Azure AD and asks for what's called a token. It's Gesundheit, and it sends off what's called a client ID and a client secret, which is basically username and password. I get back the token. That token is then presented to API Manager. API Manager says, well, let me take a look at that, and asks Azure AD, is this yours? And he goes, yeah. And we look at a couple of other things, like who's the issuer, who do you want to talk to, what are your access rights, whatever. And then if everything's okay, we can then forward that to the backend, which is super cool because no one needs to bother about access rights here. I'll just configure that once and say, this issuer, this role, and that's it. Whoever needs access, that's managed by these guys. I don't need, as a developer, I don't need to do anything here. Just once and it works. It's awesome. But let's take a look at it from another standpoint. So, a bit of repetition, but perhaps from another standpoint. Using a passport. I'm going abroad this summer. I'm going to the UK because I want to go to an integration conference. Going to the UK, especially since they left the EU, I have to go through this guy. And this guy, he's a tough fella. And in order to pass him, I went to the local police and said, hey, I want a passport. And they said, great, let us take a picture for your passport. And unfortunately, this is the picture they took for my passport. Yes, I do very much look like Adolf in this picture, and I don't like it. However, it's what I have. So I will show that to him. And he will go, is Adolf alive? And call back to the police in Sweden and say, is Adolf alive? No, he's not. It's just Michael. He looks like that. Or he used to look like that rather a couple of years ago. It's okay. And he can say, okay, I will let you through. So that's the exact same thing for how you use OAuth. I don't have time to go into the OAuth demo, so I will simply skip that. But I was supposed to say that it's very easy to set up in Azure in API management. It's like 5 rows of code, which you can copy paste from whatever, and it just works. But securing the backends, that's the 10th one. Here is a call, but let's look at the backend thing. If you have an Azure function or an SQL server, which might not be part of a network or just put up there, then these are attack points. And even though you put up a firewall and a gateway and all that kind of thing, the hackers doesn't care. They don't say, oh, I need to go into the main entrance. No, they will go through the back door if that's available to them. So make sure that you secure your backend things. Very very quickly, I'm going to show you the Azure function stuff, which is really, really nice. Just refreshing. That's what you're doing today. There we go. I think this is it. Yes, that's it. To the left here, you have something called authentication. If you click that, normally it's a blank page, and you can add something. And I added something here. I added, I said it's enabled, and it will return a 401 unless someone passes through it. And I said my identity provider is Azure AD. Now this function has an identity within Azure AD, and it means that it can be represented as a security endpoint, basically. So what I do in order to talk to this one is if I go in, oh, sorry, that was not it. No. I feel a bit pressed for time. I really didn't want to. Oh, never mind my production material there. We'll go into APIs, and I think it's the language number 4. Yes, it's number 4. Not going to execute it, just going to show you. Here are a couple of rows, which I should just point out very quickly. I can't zoom anymore now because you won't see anything. Never mind. I will read it out loud to you anyway. It says, use a managed identity authentication on this resource. So this is a GUI that points to my function that I provide an identity for. Store that output in an MSI access token variable, and then create an authorization header and put that thing back as a bearer token that I just received. So it's OAuth. It's using OAuth under the covers, but what we use called a managed identity instead. And that means that I have no usernames, I have no passports, I have no kinds of expirations or things like that. I just put this up once and they can speak to each other. If I were to call the function directly, it will respond back and basically say, you can't do that because you're not authorized. And then I go through the API management thing instead, and I can just have these kinds of, these rows instead, and we'll do all the authentication. Once again, pressed for time, I've just mentioned that you can do this on your SQL servers as well. And I think MySQL and a couple of others, where you can have the same kind of authentication thing, where you can have your function, again, have an identity, be a user in your SQL server, and no more username and passwords. No more SQL username or SQL admin name or whatever stored in a configuration file somewhere, not even in a key vault, because you don't need it, which is really awesome. So start Googling about that. Now we're coming up with the home screen. I have 1 minute left. Gonna run a little late, but only a little. I'm going to present this in a recap in an order of start implementing this thing now. So the first one is super duper important, and then it comes less and less important to do now. Okay? Of course, if number one, use an API key once again, and also making sure that you put it in the headers. Very quick side note: the reason why is that if you send this to somewhere, within your enterprise, they usually decrypt the traffic when it arrives in the gateway. So it's logged because you want that thing in your log. And they then log the address, but they can also very easily also log the query strings. So therefore, they will log the API key in their logs, and it's available, right? So you don't want that. That's why you put them in the header. Once again, it's decrypted, but it's not always logged. It doesn't always log headers. Start using your products to try to bring order in your usage of API keys. Then look at how you can update your global policy. Very easy, very quick. Start adding these very easily and available alerts, so you just know that something bad might be happening. Then start utilizing logging, because then you can basically see what people are using your API for, or rather the malicious people are trying to use your API for. Start thinking about using OAuth. especially in cases where you might have things like, I have employee data in one of my APIs. I wouldn't dream of exposing that data over just simple API key API. So that's protected from OAuth. If you had that kind of data, but your security guy says, well, you can't expose that because it's too, it's too unsecure. Think about, you can actually use OAuth on top of those things, and you can expose that data to people that need it. Then go on and securing your backends. It's super simple. You don't even need to put them into networks. You can just do OAuth instead. Then start thinking about using the application gateway. It's kind of hard, takes a while. You need to have all of your clients start using that other entrance instead of the main entrance that they used to. When you're configuring the application gateway, of course, then use WAF. And then at the very end, of course, you can then put things in networks if you really want to. That is my last slide. I would like to thank you very much for keeping awake or alert. This is my GitHub thing that I was talking about earlier. Everything that I've shown you today, including, of course, all the things that I didn't show you, is available in this thing for download. You have bicep files for all your infrastructure needs. You have API ARM files, and you have also a little cute Azure function that I built on top of that Trafikverket API thing. So thank you very much for your time, and welcome next speaker after a couple of minutes. So
I mean, I'm in the stuffy room with you guys. I know what I think. That's also the duck Well, I promise me I was no, most of the few days I was there was terrible and I hated it. This year wasn't good. Last year we had 20 days in February, it was insane. But then the week after, we were ice cream. It did not make sense. But I know go to music, go to the gig, last year. And then we had a bit of my dog.
Suddenly there's a voice going, hello.
Yeah. I mean, I can plug in my laptop now. Plug in my phone, which
Are we ready? I mean, stick to schedule. And some.
So it's 11 and we're welcoming
Oh,
Emmanuel on
right.
stage with
sorry.
some fun functions.
I thought it was you starting.
Sorry.
Never mind. I'm talking to
Shall I turn this on?
Yes, please.
Testing, testing. Seems to be working well. Are we live?
We are.
We're good.
Very
All
good.
right. Welcome everyone. Fun to see so many people showing up, filling out the room a little bit more. I'm going to talk about Azure Functions. They've been mentioned a few times already today, both in terms of security and in terms of pester testing. We're probably not going to touch much on either of those topics today, but we're going to take a look at how we can get started with them and get our funk on. You can imagine funky music in the background because I didn't look up copyright laws. So my name is Emmanuel Palm. I work as a consultant at Advania Knowledge Factory, and I have been working with code and .NET for 8 to more years, depending on which language. Finding myself somewhere between PowerShell and C#, building tools in both languages these days. I am event-driven, just like Azure Functions, in the sense that I come out to events and love networking with you guys and speaking and learning. So that's a big part of what drives me. I make modules and tools, and most of them are open source. Some of the modules on my GitHub are also on PowerShell Gallery. So if you look in the bottom right corner, that's both my GitHub and the Twitter where you can reach me, and also the location of any code shown today. I also have a blog called pipe.how where I blog about these things. And I play Dungeons and Dragons, love baking, I'm a coffee nerd, I climb, and I play disc golf during the summer, now that we have sun. So let's have a look at the agenda for today. First of all, we're going to talk about Azure Functions, what they are. We can start with a raise of hands. How many here have written Azure Functions before? It's a solid part of the room, nice. How many here have written them in C#? It's about half. All right, it's gonna be fun. So we have a basic understanding of how they work, at least that's good. We're going to take a look at bindings. How do they work? How can we leverage existing integrations to other services in Azure? We're going to dive into some demos, how to get started with some of the toolings, how function core tools work. We're going to use VS Code, which has been on stage already. Some C#, some PowerShell, and some Azure, which is another tool to handle storage emulation. Finally, we will recap a little bit before going into Q&A. So, Azure Functions. Azure Functions are serverless. It does not mean that there are no servers. It means that we don't have to care so much about them. This is my favorite part about functions because I don't have to care about the infrastructure. I don't have to care about the networking. We're some network guys. We don't have to care about patching our servers. We don't have to care about so many of these things that I don't want to focus on because I want to write my code. And when I deploy the code, I want it to run in the way I expect. Azure Functions are very scalable and cost efficient. They have a lot of flexibility when it comes to cost plans, and we can use something called a consumption plan to only pay for what we use. And we also get, with that plan, 1 million executions for free every month. So it's basically free. What you pay for in those scenarios is usually storage, logging, input, output of network traffic, stuff like that surrounding the actual code. But you can also leverage other app service flavors or app service features because Azure Functions is a flavor of app service. which means that we can use app service plans that are always on and dedicated, but we can also use managed identities and other features like private networking. Azure Functions extends something called web jobs, which is a feature of app services as well. And these show up somewhere in the documentation and the tooling and variables and stuff, but you don't really need to know about them unless you dive into the SDKs. They are event-driven. This means that we can act on basically anything happening in Azure. As we saw earlier, we can act on alerts being triggered in anywhere in Azure really, but we can also do data processing. When a new file is created somewhere, we can take the content of that and do something with it and put it somewhere else. We can build mini APIs. We can put them behind a API management resource and app gateways and stuff in Azure to really handle them like a full API, even though they're small and easy to get going with. They have multiple language support, so we can write them in C# like I did the raise of hands, but we can also write them in other languages like PowerShell or Python, Java, JavaScript, and you can actually extend these. So there are people that have done this for Go and Rust and other cool languages out there. And what I like about it the most, apart from serverless, is that I don't always have to write the integrations to everything. I can leverage out-of-the-box integrations using something called Azure Function Bindings, which are usually written by Microsoft, but you can write your own as well, which work in all the languages, so that you can integrate with a service like Azure Storage or SQL in Azure for a lot less effort by simply not writing the code yourself. There are a few different binding variants. The most basic ones are, there are three types, I would say, because I also count triggers. One of them is an input binding. These are types of bindings, and input bindings lets us read from another source. So when our function app starts up, we can integrate with another source by using an input binding and read data from that source. This could be a storage table, like a database kind of resource, or we can use output bindings to put the data that we process somewhere else. If we trigger from an alert, maybe we want to post that to an email service like SendGrid, because there are also bindings for external third-party systems. And then there's, of course, a trigger. Triggers often, always come with some data, but they're not always the main point of the data bringing to our function. So input bindings are not something you can trigger your function or start your function with, but triggers are. So we can trigger by HTTP requests, like a normal API, but we can also trigger by a timer or alerts happening or new files going, being uploaded to blob storage, for example. All of the bindings and triggers are registered in something called a function.json file. And if you're not familiar with this file, chances are you've been working in .NET or C#, because this is automatically generated when you compile your project behind the scenes. If you are familiar with this, chances are you're not working with C# because you have to register the bindings yourself in this file. There's also something called an extension bundle, which registers a bunch of bindings for you. In WebJobs language, extensions or bindings are called extensions. So you could think of this as a bundle of bindings being registered for your app, so that you can leverage all these integrations without having to manually install the integrations yourself, which you have to do in C# using NuGet packages. Let's take a small example. We have a function, looks like this. We've seen the icon before, that lives in a function app, because we can have one or more functions per app. And this one has a trigger. It might be an HTTP request coming in, and it can read from another source and output to another system after doing some processing with its data or alert or whatever comes in. The trigger can be a blob storage, it can be a service bus message, maybe it's subscribed to a certain topic And whenever something is posted there, we process that or do something. It can also be a timer. So maybe once a day or every third Tuesday at 3 p.m., we can do something. And it can read from a storage table as an input, separate from the trigger. We can hook it up to a configuration table, or maybe we have some data that is being filled in to that table from a separate source that we monitor. And we can output to an Azure SQL, for example, or maybe a storage queue, which could trigger another function. So we can see how these bindings can mix and match very easily to create these nice solutions without us having to do so much logic and code to integrate with them. If we change a little bit, we're going to take a look at an example app here. We could have a trigger every day, let's say. A function starts up and it reads from the cost management API and checks how much did this resource group cost yesterday. And then it puts that message in a storage queue and triggers another function which reads from the queue. And that function might write to another table somewhere else for a separate function app to read from. And this app can be triggered from HTTP and have the storage table as an input so that it reads all the fresh data that has come in and then responds to the user back, or the client or the API that requested this data originally. And these apps can be written in different languages because they're separate apps. In each function app, they have to be the same language, but by combining languages and triggers and everything, we can still make it a nice solution. And this is actually what we're building today, or what I built. So we're going to dive into some Visual Studio Code here. We're going to take a look at how we can get started with some of the tools that are available, and then we're going to see how we can use those tools to have something like this. And this solution by the end is also found on the GitHub, which I will show. So let's see if the screen sharing is still going well. I hope so. I'm going to open up VS Code here. Seems to be working. So I have an empty folder here, but I want to start using Azure Functions. How do I do that in an easy way? In Visual Studio Code, we have something called extensions. If I go to the extension tab, you can see I'm probably too many, and I can search for functions. I have already installed them, but it's called Azure Functions. This is an official extension that we can use in VS Code. You can also write them in other editors. So if you work with Visual Studio and C#, you can do it there as well. But here you have multiple, more languages. You can write them in PowerShell and VS Code, for example. So this one is very nice. It allows us to run some commands and get better support for these kind of services in VS Code. So if I press F1, there's another, I think, Control-Shift-P as well. You get this nice command prompt up here. And I can say Azure Functions, create new project. I can also search for it.
Sorry.
Yeah.
I think you're sharing the wrong screen on the screen guard.
That's true. That's weird. No, wait. Oh, on the stream.
Yeah.
Ah, that's very strange. Okay. This is the same for me.
All right.
Let's see if I can maybe reshare here.
Because that's what we're seeing.
This is what you're saying.
Yep.
Okay. Very interesting. I'm going to stop this, and then we're going to see if we can reshare here. Try this. Are you seeing something better?
Give it 2 seconds.
Yeah. Well, meanwhile, we can select the folder that we're in VS Code, and we can use this folder to create a new project and open VS Code for a specific folder here in C tab. I'm going to create a new function project with a HTTP trigger, which is a simple binding to get some input and output. and we're going to name it HTTP trigger. Maybe we can name it show name, because the normal code that we will get will explain why. We also have some security options here. We talked a little bit about always using an API key earlier for API manager, but we can, for HTTP triggers, also specifically for Azure Functions, utilize something called a function key. We can make them anonymous, so anyone can call them, but we can also add a function key here, so that when we request this, when we deploy this app to Azure, we can also require this API key to be in the request. Otherwise, we deny the request. Here we have gotten a small scaffolded project. On the left, we see some files, and in here we have a very simple PowerShell file that outputs a little bit of the information as part of the request coming in. So we have a request variable or parameter, and we can see that we check the query for a name, and if there is no query with a name, then we check the body for a name, and then we assemble a body which we output down here. Here we push to a binding called response. So an output binding is registered with this app where we can output some value. And in this case, we output the status code, which is 200 HTTP for OK, and the body with our name text. On the left, we have a few more files, as I mentioned. Some of them are PowerShell specific, so we're not going to dive too much into that. But we can have a look at the function.json file, which we mentioned earlier. Here we have our two bindings in this case. One is an HTTP trigger. It's a direction in, because it triggers the app and has data into the app. And we can see that it's named request. So this needs to match the code that we're referring to the parameter with. In PowerShell specifically, it comes in as a parameter to the script. This varies a little bit from language to language. And now we see at the bottom that we have a output parameter as well, called response, also of the type HTTP. We can also see the auth level here, and we can configure this directly in the file, but we can also add more stuff using either just writing it like this, and then I can see get some IntelliSense from the VS Code extension, or we can once more utilize this extension to create a new binding, add a binding to my existing function here. I'll use the local project. I'll select the show name function, and let's add another binding for an output, Azure storage queue, to kind of see a part of the example that I used earlier. We can call the binding output queue binding, let's say. We'll just output maybe, output queue. And then we need to name the actual queue in the storage account that we will be referring to. So that can be named out queue, that's fine. Or maybe my queue. And then we need to authorize ourselves to this storage account. So normally, by default, we have options of doing this with the connection strings, which have the storage keys and stuff like that. There are more secure methods of doing this, but for this simple example, I'm going to show it with a connection string. So when we click this, it's going to use Azure Web Jobs storage as a connection string. So what it's really saying here is use the connection string found in the application setting named Azure Web Job Storage. Now, what is an application setting? Locally, when developing, it's found in the local settings JSON file, which should not be sent together with your project anywhere that other people will look at it. It's get ignored by default because it usually contains stuff like connection strings and such, which are secret and should not be shared. But in Azure, you can hook these up to keyboard preferences and stuff like that to have better control over your stuff rather than having files lying around. Here, locally, I mentioned earlier that we have something called Azure. In VS Code, there's another extension that I like called Azure. This is a open source API Azure Storage API compatible server. It's an emulator for Azure Storage. So we can start up our own storage locally. This is also available through NPM and other package managers, and it's perfect for CI/CD scenarios because you can do all the integration testing that you want to do right then and there, and it only pops up in like JSON files in wherever you start the emulator. So it's really nice to be able to do all the testing that you might need and then just throw away the results without having to actually deploy a storage account and such. So it's already installed, so I'm just going to go up here again and write Azure. We can start the services specifically, or we can start all of them like this. And it's going to start them locally. We see them running down here. At the bottom it says Azure bot service running on port 10,000, and then it's too big, so there are like 3 more services there. So this means that I can use them locally, but how do we do that? There's a magic string, which is a connection string when used locally, called use development storage equals true. This in Azure Functions translates to the connection string that is used by our emulated storage. So when we start this app, it's going to connect to that. It's going to create the queue named myQueue, because if we look to the Azure Function files here, we added a new binding. And this that we added to set use development storage equals true translates to that. We can actually remove this if we want, because that's also the default for our app if we don't want to change anything. Here we will post to myQueue, and we can see if we start our app. I will demonstrate another tool here. If you want to use the command line, we have something called Func. And this is what I was playing with during the presentation slides as well. So Func is the command for the Azure Function core tools, which are used in the background by the extension in VS Code as well. And we can use them to both deploy our app to Azure and get some statistics, as well as hook up to the log stream of our already deployed stuff, or simply initiating new projects. Or the most common one is maybe starting it locally to run here, because you can run Azure Functions anywhere. It's not only deployable to Azure, you can also have them running locally like this, both for development purposes or deployed to a specific platform. We can have them running in Kubernetes or other modern platforms like that. And there are some specific scenarios where you might want to use this tool for that. So now we have started our Azure function. We can see that it's saying we have a function here called showName, which accepts a get or post requests to a specific URL. And I can go to another terminal here, invoke REST method. Let's go to cheat it a little bit because it suggests earlier things. And here we're going to jump back to the other terminal first. There we can see that we have gotten a request. It's executing the show name, and we get some information because that's what it comes with. It outputs some data for us. So it says PowerShell HTTP triggered function processed a request, and then it executed here. But we didn't really give the name, so it didn't do anything. We go back here. It's going to say this HTTP triggered function executed successfully. Pass a name if you want to get another kind of output. So I'm just going to say question name equals one in the query string. You can. This is obviously depending on the basic code that is given to us as an example. But what if we want to kind of utilize this new queue that we added? We're not doing that yet. We're just replying to the user. We can actually add another call down here for another binding, which we name to output queue, if I'm not wrong, and reference the here. This is the name that we want. And it's going to take a value. So we just give it a string. Maybe we give it not that. We give it the name variable that comes in, that we have gotten from the body. And then it's going to be angry because I started changing files while it was going. So let's stop it and start it again. We can do the same thing. Send a new message here. And then it's going to say that it's triggered, executed successfully, and it now posted to a queue. How do we know? Well, because in the queue storage folder here, it created a file because it's locally emulated. So everything is happening in this directory, and all of these files are by default git ignored, so you can run them locally and kind of throw away the data. It's encrypted as we see, but this, not encrypted, but rather encoded, I think, locally, base 64. So if I were to decode that, it would say no. So that's a quick example of how to do that. What if we added another function to trigger from this? We could, by utilizing this or the function core tools again, to add a new function with a queue storage trigger here. It can be called queue trigger or something like process name. If you use the same connection, we can name the queue my queue, because that's the queue that we're wanting to read from. And I also want to stop. Yeah, I did stop the function. Good. So we already know here that the queue contains something. We haven't processed that item yet. The service is still running, the queue service on my computer from Azure in VS Code. So if I start this up, it's actually just going to process it immediately. And if we go to process name here, we can see that the default of this binding example is just to output the data. So if we run it again, we're going to see that it's going to fail because I forgot to mention something about the extension bundle. Sometimes in the host.json file, we have registered a extension bundle. We don't have to care about this so often, but sometimes, and I found when writing this demo, these versions matter because these are the compiled kind of collection of NuGet packages that are the bindings found in .NET basically. And I found that when just jumping down one version here, it didn't give me the error anymore, and I haven't really dived into why. I'm sure you can look that up online. And exactly the mapping there is found open source in their project. So now we can see that it started up immediately, and the queue trigger processed the work item with the data here. So I have a few more minutes. So we're going to take a look at the more complex example here. We close this down. That also shows closes the Azure because it's running in that VS Code. If we want to start that up again, we can do that in this window instead. Here I have the app that I mentioned. This app that you can also find without the tunnel, you can find here on my GitHub. Follow manual at Global Azure Stockholm 2023. And here you have a deploy to Azure button if you want, with the bicep file and everything that you might want to look at if you're curious about how I built this specifically, because we don't have time to go through all of it. But what we do have time to go through is how this looks when writing it in C# instead. So if I go to one of my functions called the get cost data, we can see immediately that it's, first of all, it doesn't have a function JSON file here. But if I were to do something like this, cd there and .NET, let's say .NET build, because it's a C# project. If I build it here, it's going to create this bin catalog, right? And in there, by the time it's done, it's going to have all these stuff. And in one of these here, it creates a function JSON file. So that's what's happening in the background. And it looks a little bit different, and you don't really need to care about it. But it actually takes this data and processes that for the Azure functions in the background. So by writing Azure functions in C#, we have to use something called attributes, which we put on our methods. This one is called run by default as well, but we can see that we actually name the function get cost data. And we use timer trigger, so at 6 a.m. every day, this will run and get some cost management data. Then it's going to put that back to the queue using something called binding expressions, which are ways for us to say that this name of the queue that it requests is actually found in the application setting called cost queue name. And the code itself is not super complex or super interesting, so I'm just going to show this part where it first gets a token for the managed identity. This is something that is an app service feature, so we can deploy an identity together, as mentioned earlier as well. So we can give that identity specific rights to our storage, for example, and we don't really have to do more interesting secrets handling in local files and such. In this case, I've given it the role of cost management reader, which lets it read cost management data for its own resource group. So the whole purpose of this app is to cost money and see how much it costs. And then it posts this by returning the cost data as JSON, which it happens to be returning to the queue. That's how we output from C# in this case. And we have a separate function which triggers from this and returns it by outputting it to a table after doing some processing and some C# modeling to make it look nicer. So if we run this, we can, well, I haven't actually set up all the stuff locally because it's using a managed identity, but I have deployed it to Azure. So we can run it, but before doing that, I want to also show you the other part, the PowerShell part, which lets us invoke a Azure function and get all this data from the storage table. We can see in this Azure function JSON that we have an HTTP trigger, HTTP output, and a table, which is an input binding, reading from these application settings that I haven't set up locally, but are found in Azure. So if I go to my Azure resources, this is how it looks when it's deployed. And I have two apps sharing the same app service plan, so they share the same cost and in this deployment at least. And I can see in the C# one, for example, if it loads nicely, I can look at the configuration on the site, and it will show me the application settings about these enormously long seconds on stage. Okay, it's taking a few moments more, but that's fine. So we can actually do this instead. I've already tried it. So the PowerShell one actually just takes an HTTP one and outputs the data from the table. So if we run this in PowerShell, I'm going to get data because I built this demo like a week and a half ago so that there would be data to show. And you can see that it's incredibly pricey. It costs me about 0.2 crowns per day at most. And if we go into there it is. I want to show you two things here. First, if the configuration loads nicely, I want to show the app settings because they show up as environment variables when running the code, so we can reference them. There's nothing really secret here in this demo, so I can show you that it references the cost table name by using a setting here. Cost data table is what I named it. And we have some settings here that are specific to C# and some in other ones specific to PowerShell. And all of these are also found in the bicep code in here, where I've set all these things. But if we go into one more interesting thing before returning to the slides, we can go to the cost analysis, which hopefully loads in a reasonable time. We can see it's not so expensive. And when using the scope of this resource group, if it loads nicely, we can see what actually costs money here is the storage, and then the logs, and then the functions is like 0.01 crowns over the past 1.5 week, which is pretty cheap to me. At least we can afford it during the rough times of inflation. So with that, I'm going to jump back in here and see if we can get the slides output nicely. Great. So what have we learned? If we go back, we rewind a little bit. Azure Functions to me is a service for just running my code. It lets me take the code that I have. Maybe I already have a script on-prem in Python or in PowerShell, and I want to just integrate it and kind of run it in the cloud somewhere. I have some old runbooks or a server that I want to decommission. I can easily move them here, or I can easily build new things and integrate with services very easily with both pre-made integrations and authentication by using system-assigned managed identities, for example, or other things like great integrations with Azure AD. So you can actually enable only Azure AD authentication for the requests coming into the function as an extra layer of security. And it's very, very flexible with not only languages, but also the bindings, integrations, the feature that come from the app service, as well as being able to extend all these very nicely with the SDKs available if you want to dive deeper. And with that, we have arrived at the Q&A. And if you're curious before any questions, you can always look at the code on my GitHub afterwards. So, any burning questions about Azure Functions? Yeah.
So if you're running PowerShell scripts, when should you run Azure Automation, and when should you run Azure Functions?
Yeah. So the question is, when running PowerShell scripts, when you want to use functions versus automation accounts in Azure. The main point, the only real reason I still see to still use Azure automation accounts is when you need a hybrid worker, when you need some on-prem connectivity to request data from like a database or an API that you have locally on premises within all the kind of gates and security that you have on-prem. So if you don't have it exposed publicly, you might want to use an automation account with a hybrid worker. But in pretty much all other cases, I think Azure Functions are superior in not only cost and management, but also just stability and integrations and logging and all the stuff that you get kind of for free with the service. Yeah.
So if you have a VNet integration on the app service plan where the Azure function is running, and you have a VPN tunnel or an express route to your on-prem stuff,
yeah,
then there is no reason to run an Azure automation account, basically.
Yeah. So the question is, follow-up question is there a reason to still run an automation account if you have private networking and on-prem connectivity through that network with the Azure function? I don't know a reason to still do that unless you need Kerberos kind of AD accounts to run the auth to the on-prem APIs, because then you need to do some certificate magic to make that happen, because the Azure function does not run with an AD on-prem account as opposed to a hybrid worker service.
Cool, thanks.
Yeah. Question?
Addition, the reason could be because it can be cheaper if you have very long running tasks. If you run them on premises, then you can save money because you're not paying for the Azure function in it.
Yeah, so an additional note here is that it might be cheaper to run Azure automation accounts with hybrid workers because you're running on existing servers as opposed to functions that you pay by demand, and especially for long-running jobs, which is true, but there's also something called durable functions, which let you handle long-running jobs very nicely, even in consumption. But yes, that is a good point. So you can compare those two options as well. And then there are also obviously other services like logic apps and all these things to kind of orchestrate things for you. Any more questions? One more?
Yeah, if I can.
Yeah, absolutely.
When you're developing your functions, what are your guidelines for creating tests and general workflow?
Yeah, general workflow for when I develop my functions. I use, depending on which language I write them in, I sometimes use Visual Studio for C#, but most of my functions are written in PowerShell, which I use in VS Code for. As for pester tests and such, is what I would go to for testing my functions probably, because the script itself is only really a script, unless it has integrations to other services that you can't really emulate so nicely on-prem. In that case, I think you probably want to set up like a mock API and try some things with it in Azure, or maybe a test environment where you set up the application settings to things that you can kind of test surrounding it with data, so you don't really integrate with all the services you might have in production or such. Other than that, I think Azure is a fantastic tool to emulate everything and even do integration tests during your pipelines when you deploy or before that. So every check-in, you can really run all the tests and make sure all your functions are working, assuming you're only really working with tables at that point, which is not always the case, of course. But it's a good addition. Yeah, I think those are the tools I use for creating functions. But there are some nice guidelines on docs from Microsoft on how to develop locally and do these things. And it also depends a bit on the language you prefer. Yeah. All right. Thank you very much.
Good job.
Nice.
So we want to start in the room in the back. We have poke rolls. There are two alternatives. We have one with salmon and one
Okay, welcome back. Hope you all had a nice lunch. It's good to see you, most of you back at least, I think. It's time to talk a bit about CD. Or, one of the main issues when doing sessions about this is, we can't really agree what CD actually is. So I decided to opt for another one instead. So instead of CD, we're going to go with very important non-clicky launching or vinyl, because it's way better with vinyl, of course. Sorry about that. I just had it input 2 minutes ago. A bit about me. My name is Björn. I do stuff. I work as a consultant at Albania. I write stuff, I create stuff, I share stuff. I also walk my dog, play the guitar, and I love to cook. I was also told a couple of sessions ago that you have to have a hoodie in order to be cool. And sometimes I do security presentations and use this one instead. So here's my hoodie picture, just so you know. I'm also a hacker sometimes. I'm absolutely not a hacker every time, but I like it. Anyhow. We are going to talk a bit about this, the agenda for today. What is CI/CD? Like I said, we have some troubles defining it. There are so many interpretations of it. So we're going to sort of mention what it is, or my interpretation of what it is. We're going to look at where we start, not demo-wise, but more the requirements for deployments. We're going to look at some building, or building in a very loose sense. Adding some infrastructure. And at last, finally, we're going to talk about how to do the dev test stage, whatever production deployments. Now, I was kind of worried that this session wouldn't be enough Azure for global Azure, but it turned out it worked out fine because I'm going to use Pester and functions to do all my demos. So hopefully this will be Azure enough for you anyway. So let's head first in. I did not know I had transitions actually. Okay. CI/CD, what it is? Well, the short of it is continuous integration. That one we sort of agree on. CD is more of a flexible term. We say continuous deployment or continuous delivery. It seems to be somewhat agreed that the main difference is that delivery still has some manual parts to it. You can do continuous delivery up to a sort of limit or whatever, whereas deployment, that's 100% automated all the way to the end. There are a couple of keywords that this should circle around. Stability, repeatability, and frequency. Those are the 3 keywords we will come back to all the time. And in that order. Because one of the things I experience a lot is that people, when they start to do this, is they start to talk about, we need to do releases, we need to do fast releases, we need to get our stuff out of the gate as quick as possible. But frequency and speed should always be the last sort of goal. It should be what you go to after all the rest is done. Because the result otherwise, if we don't put frequency and speed last, is that we will deploy shit stuff really quickly. We need to have stability and repeatability first. So, where do we start? We start with CI, continuous integration. And what is this? Well, the art of merging your code into your main branch or your release or your stable branch, so to say. Before we even start to look at deploying, we need to have some strategies for continuous integration in place. We need to have proper test coverage, like Jaap showed us. Because if you don't test your code, again, we're going to deploy crap into our pipeline really fast. So we need to have proper tests. And this goes no matter what language you use. We need to have some kind of, well, most commonly unit tests. If we do infrastructure as code, you should have tests for your bicep or arm templates. You can use what if deploys as tests. That absolutely works to a certain extent. What if deploys has flexibility problems, but it kind of works. We need to have linters where we talk about, when we talk about programming languages, not just because linters are fun and cool and do stuff, But because we have code standards, we have ways of writing our code we want people to follow. We don't want people to have clear text passwords in. A linter can take care of that. We also need whatever security scanners we have in place or whatever security requirements we have. So static code analysis and so on and so forth. And we need to have a Git strategy. This is something also many people sort of miss out on, but it's needed to design the deployment strategy. If we don't have a strategy for how we do Git versioning, then it's going to be really hard to set up your triggers when it comes to deploying. See if my screens work. Hoping that the shares work as well. How can this look? Well, a bit like this. I'm not going to go through the code because it doesn't really matter in this case. In my pipeline, I'm running PowerShell because PowerShell is my language of choice. We have a secret scanner because I like to promote my secret scanner that I know. Script analyzer is the linter we have, and we run our pester tests like that show. Also publish them. And if you don't have this in place, please go back and start by doing at least a baseline of this, set up a strategy for this. This writing tests is one of the hardest parts. Getting started with it, just like I really like the suggestion Jaap gave. Whenever you have a bug or a problem or an issue, before you fix it, write a test for it. That way you will increase your test coverage quite quickly. Once you have sort of the stability in place in your continuous integration, that's when we can start looking at deployments. And I really don't like that it takes such a long time to do this. So the first thing we're going to do is to build our code when it comes to deployment. Now, I use build in a very loose term, mainly because I'm a PowerShell nerd, and PowerShell isn't really built language. You can also see it as creating an artifact or a result. So why do we do this? Well, of course, some languages needs to be built. You can't run anything if you don't compile your C# code or whatever. But it's also about creating a long-lived package, because delivery, or when it comes to deployment and delivery, the important thing is that we need to know that the exact same code that we once tested is the one code that will be run in production. We need to have a package, an artifact, something that lives through the entire deployment process. Because if we make changes, if we don't sort of create this package or have this done package that we run through our deployment, and something happens to the code in the middle, suddenly we're not testing what we're deploying. So we need to have a long-lived package that can live through every stage. Another reason that I personally like is because it's sort of the last chance to check that everything actually is okay. So just like we do with CI, run your linters, run your unit tests, run that stuff again, just to make sure that nothing happened. Extra security. When you do this, you do your building, your construction of packages, we need to tag them. A tag can be anything. If you're used to working with Kubernetes, you know that it's even highly enforced to use tag. We can use versions, we can use dates, anything else. I'm going to demo a nifty little tool. I hope that I can get working. Come on. Yeah, this is fine. Let's start a console. We're going to look at a tool called Git version. Git version is a fancy little tool built into most pipeline environments that we can use, that is created to manage versioning for you, help you with versioning. So in its sort of baseline, we can run the exe like this. This is of course cross-platform. I run an exe because, well, I'm on Windows. You can run it in Linux or OS X or whatever. It outputs a JSON table, and it contains all kinds of fancy fun data that you can use to version your artifacts. The nifty little thing it does is that it counts the commits in your repo. So it can actually count and see which version should you be. If you also have a strategy for tagging your commits, it can actually do major, minor, revision, all kinds of versioning for you, and you can just use this to tag your packages with whatever you want. Of course, we can also do, I need to check on my cheatings here. There we go. So right now, it simply says 010 because that's the default version of Git version. It does this if you don't do anything. We can also apparently not run Git version. Oh, wait. We do this. We can also create a config file, and in the simplest version, just tell it, okay, I'm on this major version, and it will do the same. It will count my commits through this and sort of fix everything for me. So Git version, fancy little tool for tagging really good stuff. Don't forget to tag your build packages. It can also, if you're using C# or JavaScript, it can also inject versions in your build process and actually automatically create version DLLs and so on. This is really cool. So use something like that to tag your packages. Now I have a short demo that I want to show as well. Yeah, could you please bring me my charger, because I'm running out of batteries here. So another cool little thing that I wanted to show is a question that I often get is if we have multi-project repos. I have many projects in my repository. I do not want to build everything at once. We will get back to the sort of scenario where this is useful. Thank you very much. In a while. But while I'm in the console, I thought I might just take the chance of demoing how sort of I set this up. So we can use Git to check out versions. If we just use Git, it will tell us all we can do, how Git works. I hope by now you're using everything as code. Again, I need to use my G. We can use git diff and do this, and it will tell us that between this commit that I'm at now and the previous one, these are the files that changed, only the names, because I only need the names, and some PowerShell magic or some scripting magic to do this. So we can have multi-project repos and only build the stuff that's actually changed. That way we can also come back to incremental builds, which I will mention later as well. So, leaving the console, I just wanted to show that while we were there. How can this look? Well, again, I'm using PowerShell. I use a invoke build, which is a PowerShell module. It works really well. It has some quirks in it. I'm not going to go through the details of them, but it works really well. It also has built-in functionality. So if you're using any .NET language, pretty much, you can use invoke build to build and create all kinds of awesome build scripts using this. And let's see if we can zoom. We can do stuff like this. We actually use Git version. We get the version that we have. It calculates major, minor, and release tag in this case, because that's what I wanted to tag my build with. And down here, we do some magic with the module manifest, which is where versioning in PowerShell happens, and we can just insert our version there. That way, whenever I do a new release of my module, it will automatically bump it to whatever build number we should have. And it will count my commits and see that, okay, you have done so many commits, so version is now that, and so on and so forth. Because I keep it simple. Again, if you want to do it advanced, you can use tags for stuff, but tags is not for me. Once this is done, once we have created our build script, of course, we need to add it to our pipeline and just make sure that we, I hope this is visible. Oh, there we go. That we publish it as a pipeline artifact. I promise I can't speak sometimes. What this comes down to is because once I've done this, I know that this pipeline run, this deployment run, will have the same code every single time. I know that whatever is in this build, in this binary build folder that I created, is tested, verify it works, And this is the code that will run through all my production environment. Goody goody. Back to slides, because I love jumping between windows. And why is it so dark? Oh, that's why it's so dark. Okay, so we have built our code. We kind of know what we want to do. We are going to deploy I am going to deploy a Azure function that uses my module as a backend and runs a code through it and does some magic in the Azure function and outputs a fancy little integration test stuff or fancy little line of stuff, things and stuff. In order to do this, of course, we need to add function or add the function code, the actual hardware or the infrastructure. In this case, I opt for Bicep because Bicep is a cool language. So I wrote the function code, the code to set up the Azure function in Bicep. Again, need to think about packages. So this Bicep code that deploys my Azure function is the exact same Bicep code that I wrote in production to deploy my production. Because if I have a different sort of template that runs in my production environment and my test environment, well, I don't know if it's going to work because I have two different environments. What we want is the end of it works on my machine. When we run integration tests, which is sort of the first thing we will do now, we want to know that the integration test that we are running will be run on the same kind of hardware, infrastructure, setup, network, everything as our production. We can, of course, use stuff like Git tags and lock our infrastructure and say, okay, this particular function runs on this particular template with git commit ID or git commit tag, yada, 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 and so on and so forth. That way we know that if we redeploy the entire function, it will know that this is the version, this is the version that worked. Whereas if someone continues to develop this function, change functionality in it, we can actually test it before and make sure that everything behaves the same as well. One way to do this, not necessarily the only way, but one way to do this is keeping your infrastructure code a separate repo and then including that repo instead. That way we can separate development of our infrastructure and our code, because even though they live kind of together, the life cycle management of them isn't necessarily the same. So, I forget. The first goal, what we're going to look at when we do this, is to run integration tests and performance tests. Azure functions, like Emanuel showed, doesn't cost that much to run. But for an integration test, we can actually save even more because they can be ephemeral. If we run everything as code, if we template our infrastructure, we can just spin up 1, 2, 10, a million new Azure functions and run our integration tests against those machines. That way, we spin it up, we run our integration tests, we destroy all our testing environment. It doesn't cost more than a couple of öre, and we still know that it's the exact same environment as in production. We could also use something like Azure load testing to test loading of this machine. Now that will increase the cost, and I do not have a demo of it because I kind of realized that I forgot to create a demo of it a couple of seconds ago. But we can also add load testing and see that everything works as expected. We haven't slowed our code down. If it does, break the pipeline, stop it, and go back and explore or see what went wrong. We are going to run all of this from a Azure VM scale set because they are also cheap and simple, and we can also do such nifty things as using a managed identity to set everything up and say that this managed identity is the only one that has access to deploy stuff. We can lock it down and have separate VM scale sets, separate identities for the different environments. We can do all kinds of cool stuff with these things. And VM scale sets are actually one of my favorite things in Azure. They are just so flexible, and I use them for all kinds of fun stuff. One of the things we need to think, actually back to the same thing again, packages and standards, is dependencies. We have a lot of dependencies when running a pipeline. So I use PowerShell. Yeah. We use, for example, Azure PowerShell to deploy our stuff, and to build our stuff, to do all the things we need to do in Azure. My recommendation is not by any means enforced, but I prefer to save the dependencies into my pipeline in this way, mainly because then I know which versions of the Azure modules I run, and also because it's actually faster, I trust it more, and in some cases it's even down to the point where my build agents and test agents and run agents may not even have access to the internet, which means I can't download anything from the PowerShell gallery, and so on and so forth. So let's go back in. Just look at another report. Like I said, in this case, I'm separating out my bicep code. It's quite a simple setup of an Azure function. Uses bicep. I'm not going to go into the details, but what's important to notice is that we can parameter, yeah, you know the word, parameters, and which allows us to use this template for whatever environment we want. We can use this template to deploy test prod, and it will look exactly the same, apart from the name, of course, even down to the region. So I choose to have this in a separate repo, like I said, mainly because then I can deploy or continue to develop my bicep code without interfering with the rest of my code. I don't have to go through this, and I can also reuse this for every single function, no matter which one I run. They all look more or less the same. And we have our code. Again, not going to go in and look exactly how it looks inside, but in the build step, I said we need to publish it as a pipeline artifact. Because it takes time, I opted not to do this in this case, but instead just faked it and have a bin folder in there somewhere with my compiled code. Doesn't really matter. What we're going to go into doing here is deploying this this Azure function. So a lot of PowerShell code.
Yeah. Sorry.
What?
We only saw your senior slide.
Is it stuck?
Yes.
So,
I'll see if I can reshare.
yes, please.
Present. Share screen. Oh, yeah, it's because I have done dual monitor.
Don't do that.
Let's do it like this instead.
You have to allow it to one.
What? Okay. Oh, no. Allow what? Is it working?
I don't see it.
Yeah, I promise you that. I'm a tech. I promise you. I know lots of things about the computers.
Would be a live demo with that about.
Exactly. Yay! Is it working?
Yes.
Good.
We see StreamYard. Yeah. Yay!
Nice.
Please continue.
Fantastic. Okay. So like I said, trying to get back on track, separate repo, bicep code, we're going to deploy and set up our function. Now, because like I said, this is just for integration test and load testing and stuff, we can do something like this and just generate random code, random names for all our functions. Because again, it doesn't matter, this will just spin them up, run our tests, and destroy our entire environment. And it will cost us about a couple of days. So we're going to generate everything dynamically, just random GUID, take away some characters, deploy our function like yay. A lot of text in here. And we're going to use zip deployment because it's easy instead of using the actual task because the task is dumb. We're going to use zip deployment. I can explain why if you're curious, but not now. So I'm just going to compress it and publish it as a zip deployed Azure web app. Now, the issue with running free Azure Azure functions is that they have a short sort of startup time. It takes like a minute and a half to upload the file, and then it takes a minute and a half to actually start the actual function. And because I'm a cheap bastard who runs this on free versions, we're just going to add some sort of sleep like this to make sure that the function actually has time to start. We could probably use some nifty little PowerShell code and just try to ping it and redo until it starts, but this works. It's simple enough. And like I said, speed is the last step. That's where we get when we get stuff working. Once it works, then we can start to sort of improve this. I use Pester for my integration tests as well, because Pester is a fantastic tool to do testing of APIs. And since an Azure function is an API, I just call it. And this Azure function will in turn use my module that I just built, and I have as a static artifact by now, so I will know that everything is the same. It will run this, it will call my module, and it will return whatever we want. After this, we will go back and publish it as a test result, and if everything works out fine, we will publish this as a universal package in this case, because universal packages are fancy. It's basically a NuGet feed. So it will take all of our code, all of the stuff we've built, including the templates for setting up infrastructure, parameters, everything, and publish this as an artifact. It will tag this artifact with the version that I choose to set. I actually cheated and just set next version. But it will tag this and make sure that I can republish this exact deploy anytime I want. If you come to me in 3 years and say, oh, we had problems, a bug in this version that's 3 years old, give me a version number and I can redeploy it in a new machine. No problems, because we made the stuff. So, how does this look? Well, there's a lot of steps in here. But what's actually interesting is this. Like Jaap showed, default output from Pester. I actually opted to get some more output, so I said output detailed, so I can see the functioning, the working tests as well. We also have test results in, in the actual build pipeline. This is one of the built-in features in Azure DevOps. It's quite cool. If you use the -CI, that's why I know it. If you use -CI and output it as JUnit, it will automatically snap this up and say that everything works. This is how many tests you have. You can even have some statistics, and your manager will be really happy when you come with an Excel sheet and looks like, I deployed so much code and it's all green, and I've increased this much test coverage and it's all fancy, and they will be so happy. But it's a bit slower than expected. Well, okay. It works anyway. And by that, we have added some infrastructure to our code. Now, like I said, the resulting package, I'm lazy. I don't know if I even tagged it. But I published this here. And this is, of course, a zip package. I can deploy it in a pipeline anywhere, or I can just go here and download it and run it on my local machine using fake Azure functions, whatever they were called. I can't remember the name. So this is everything I did. This is the exact snapshot of this environment that I just built. Oh yeah, I forgot to show you, but I'm running this fully internal with no network, no external network. That's I can see. Come on. If we okay, I forgot where I put it, but everything is run internal on a scale set, so if we should be able to see it here. We have our agent name, and this is an internal machine that uses managed identity for everything, so I don't even have to have access to the environment I'm testing. I have access to this repo. That's everything I need. Now, there's a good reason for this, and that is that I can't go in and break anything. Because otherwise, if I have access to this environment, it would be so easy for me to just go in and fix if something goes wrong. And suddenly we're back to it, works on my machine. Keep your packages static through the entire CD pipeline. Vad du har någonting mer? Jo. Like I said, oh, there we go. Hey, come on. There we go. Like I said, I also included the modules in my pipeline or in my repo. So I have the static modules. I know exactly which versions of everything I'm running. So like if they do a breaking change, I don't care. And it sort of speeds up my pipeline a wee bit. And I don't need to have a network access machine. There we go. Okay. Back to seeing if the stream is working. Good. So we have added our infrastructure. We have run integration tests. Like I said, we could also add some load testing if we want to make sure that we haven't written bad and slow code. But this is where we are. It's time to deploy. Now, why do we do this? All the dev test, integration test. Well, stability, of course. We want to find errors quickly. We want to find issues as soon as possible in our code. This is what the sort of culture we're working in called shift left. We want to shift it as soon as possible in the pipeline. And if you have set this up using templates, if you're using static builds like this, it's actually quite a small step to add a production environment, because we already know that the environment will look the same. We are using Bicep, which is idempotent, which means that as long as we don't change our Bicep templates, we can redeploy the same template over and over and over again. It will just say it's fine, nothing has happened. Let's just keep doing this. And this way we can keep our test environments dynamic and short-lived. But our production environment using the same templates, we just have to not remove it. That's sort of the only thing we have to do. So in order to deploy this to production, well, I know it sounds short and I like to say it's very simple, but what we need to do is basically add a lot of if statements, parameters, evaluations to sort of see that everything still is okay while we deploy it. Is it the correct version? Should we deploy the latest or the previous versions? Like a bunch of data structures, basically. But we also need to have our branching strategy in place. Because if we do this, if we want to deploy it, well, we could, of course, deploy everything from main, but we need to know that we're deploying everything from main. We need to lock everything down and make sure that everyone that does something with this code knows where the code is coming from that goes into production. Again, stability. So I would say this is where your branch strategy really comes into play. For me, I prefer to do trunk-based development, which means basically small jumps, have a main branch, just write code, add it to main, write code, add it to main, trigger your integration tests, CI, not integration, unit test, your CI pipeline on main. But when you do a release, just break out the release pipeline, run the release, break out the release branch, run the release or deployment pipeline from that branch, and then lock it down. That way, even just like we can go back and find a package with what we did, we can also just go back in our Git history and say, check out this one, this little feature or release branch here. It's easy to remember. So release branch is something I like. We could also take the chance to add some more gateways. This is kind of Azure DevOps specific, but we can use stuff like extends templates or templating to add gateways to make sure that, okay, in order to publish to deployment, it's not enough to say that you need to run our security scanners or whatever tests we have on our production environment. We need to enforce this. You cannot push this here. We can use this separating templates and extend templates to do this. We can say that this repo where no one has write access but me because I'm head honcho great master. I set up this template that says this is how we run security tests on our production environment. And if you do not inherit this template that only I can create, you can't deploy to production. That's it. Azure DevOps will actually break and stop your pipeline. We can also do sort of cool stuff like, no, I lied. We can do really, really terrible stuff. Okay, sorry. How many here uses a CAB change advisory board? 2. That's too many. Sorry, I really don't like change advisory boards, but they have their place and they're quite common in the production environment of today. And we can automate that as well. Just set it up, push to production, break our pipeline, send an email to our change advisory board and say, okay, when you're ready, whenever you feel like it, go in here and click OK, even though you have no idea what this code does, because I've never met a CAB that actually knows what your code does. But they sort of need to feel, oh, but this is the big red button. I want the big red button. Okay, sorry, ranting. Okay, we can do this automatically at least. To create this change advisory board task thing, whatever it is they want. We can do all kinds of gateways like this by using built-in functionality in Azure DevOps. Why I don't like this is because, like I said at the beginning, the difference between delivery and deployment, having a stop button that says someone needs to go in and approve it, well, we're going from continuous deployment to continuous delivery, which is a step backwards. Okay, so yeah. We can also, of course, set up, again, like I should probably do a demo sometime of, but I don't have the time right now, of zero downtime deployments, blue-green deployments using Azure Functions or using your API manager to shift over to a new environment, all kinds of fancy stuff. And we can do this to run smoke tests, of course, on our blue-green. So we slowly move over our users to the new environment. Or, of course, like a proper good developer, PTMF. Push to main every Friday. Just make sure it runs in production. Now, there's an awful lot of code in here. So I'm not going to show you everything. Because, like I said, this kind of what you do is add a bunch of if statements and a bunch of sort of evaluations of parameters and conditions like this and so on and so forth. But the result here is that we have a pipeline, it's hard to see, that when run on main, whenever someone pushes code to main, we will run all our all our unit tests. We will run our security scanners, and we will run our linters, everything like that. And we will sort of build and publish all of this to the pipeline and make sure that, yep, it works. After this, a new step. Still running on... What are you doing? Still running on public machines.
Sorry.
That builds our artifacts, because building doesn't require me to access everything. So we build like this. Now, we also need to have some magic like this, because Azure DevOps made a bad change a couple of months ago that made Git version stop working. So we had to fix that. We run our build script, we create our functions, and we publish our function code. The Azure function zip contents as a pipeline artifact. If everything works, and in this case, since we have set up a branching strategy, if everything works and we're on a release branch, we'll continue running and run our integration tests, because integration tests are per default, per design, slow. We do not want to run them every time, because then we would end up where Jan said, we sit for 15, 20 minutes, an hour, and wait for them to be done, and I forget what I do, and then we're doing something else instead. So again, randomizing some parameters, setting up tester, running our integration test, and publishing this to our pipeline, so we have this beautiful graph of how everything goes. And if everything goes well, remove it. If it doesn't go well, we could, of course, leave it there to explore and see what happens, and publish it internally as a universal package that we can then download and continue running and rerun and so on. Last but not least, we're doing the deployment. Now, deployments in Azure DevOps looks a bit different. Instead of just having a job and a state, we say that this job is of type deployment. We have to give it a name, we do some other magic, we have to have a strategy. Like I said, this is the place where you can do blue, green and stuff. Azure DevOps actually has support for this using the strategies. For me, again, I'm cheap and simple. I just say run once, kick ass. No one remembers a coward, right? We deploy this universal package. Now this one, like I said, we need to be able to redeploy and deploy other older versions as well. So we can actually do, okay, somewhere in there, there's code that says that we can start this pipeline. Instead of running it automatically as our CD pipeline, we can say just spin up a machine and run everything set up with this particular version. And since we have packaged everything, including our bicep and our everything in a universal package, again, you can come to me whenever you want to and say, I have this bug from 3 years ago. Which version are you running? Oh, 0.1. Good, let's spin it up. So we template everything and we publish it. Simple as that. So the release strategy or the deployment, if we do the starting work good enough, deploying to production is actually the simplest part of an entire CD pipeline. Like I said, I have 1 minute left. We can also do fancy stuff like this. So I have an environment. I set it up in my release strategy. If we go into it, we can see that I have some failed. No. We can do like this. Okay. I think we have a John in here. Yeah. Whenever someone needs to deploy to my production, it will send a mail to my colleague John and say, you need to go in and approve this before. And the CAB board will be really happy, and I don't have to lift a finger to touch the CAB board because I don't want to touch it. So make it a runtime. We can also do this one. I hope you see it in the back. Required template. Like I said, if we have set everything up, if we're using extend templates, we can say that, okay, this template is what we need. If you do not run our security scan, we can do this. If you're really, really awesome and fantastic and want to do it super advanced, you can even do call an Azure function, which is kind of a lie, because once you click this, it just says what API should I call and what response do I get? So you can actually call just about any API and have all these approvals and checks in place so that your managers and everyone is happy and everything is stable. And hopefully, come on. Once we have done this, we have achieved our magical trio. If anyone saw me last year, this is the exact same image I used last time. Stability. Well, we have stability because we test our code, not once, not twice, but actually 3 times in this pipeline. We run our linters. We run unit tests in CI and CD. We run integration tests against the build with the current iteration of the environment we're running. Repeatability. Well, everything is scripted. It's automated. The only thing, or the only person that has to touch something when I create a release is John, because he has to approve it, because he's the CAD master. We have published our artifacts, which means that we can redeploy. We have idempotent, because our infrastructure is built using an idempotent language and templates. Frequency, though, well, that's for next year, I think, because it still takes 10, 15 minutes, and there's a lot of places we can start improving this. But like I said in the beginning, frequency and speed always comes last. If you haven't got stability and repeatability, then you only will achieve deploying shit code faster. And hopefully it will just run magically all the time in the future. And I never have to touch this thing again. Or you don't, because I love doing this shit. So with that said, come on. Questions? Shoot.
How long did it take you to set up this pipeline?
I mean, this is more a consequence of older stuff that I've done. I would say it takes like half a day, maybe.
So for a normal human, 4 days.
Yeah, it depends. Like I said, repeating the question. The question was how long did it take me to create this pipeline? I do this all the time. I do Azure DevOps stuff, not just as work, but at home, because I think it's sort of the most interesting part of Azure. Deploying stuff and getting stuff from here to there is, once it works, I lose interest. That's sort of someone else's problem. So yeah, it's half a day maybe. It depends, of course, on requirements and how much do the client, the developers actually know. Like most of the time, the longest process is actually figuring out what a release is. No, they say, you come somewhere and they say like, okay, so we write a code and then we deploy it to production and this is it, and then we just, this is what goes on. So, okay, take a step back. See, what do you do? Well, we build our code and deploy it. Okay, so what is building your code? Well, we click build. Okay, that's good, but what happens behind the scenes? What's going on in your build scripts here? What's going on in your PowerShell code that does everything? When you say you deploy it, which environments are you running it against? Which sort of environments? That's sort of always the biggest process, figuring out this. Because, well, just like every single, or just like always when writing code, the simplest part is writing code. The hardest part is figuring out what to write. Like, if you know a language, that's the easier part of it. And since this is a demo, well, I knew what I wanted to deploy. Like, okay, now I'm going to do this. Done. Good question. Good answer. Cool. Any more?
Kind of recommend release branches over main and commits for versioning. What's the real benefit and what's your policy for maintaining those release branches?
Releasing branches is not a what's the main reason for release branches versus main only and deploying from main? Well, I mean, trunk-based development allows you to release from main. And if you trust your process, absolutely, that's easier and requires one less step. For me, it's mainly because I'm a human and I like readability. So if we actually go look at, okay, where did you go? Thank you there. Branches. Oh, sorry. Let's just. Yeah, so if we just look at this, this is sort of how I structured this one. And this is the date that I created this release branch. I will never develop anything. I just break it out and then lock it. So the main reason is that when I have 100 old releases, it's just really easy to go, the 5th of May 03 was this released, this code. Of course, I can go back using Git history and just check that version as well. But the commit IDs, well, they're the same. It's just because readability, actually. So there's no functional benefit to it. It's just that I'm human and I find this easier to read. Good answer? Hope.
Great, thank you.
Thank you. Any more? Okay. Go home and deploy some functions. Thank you.
Jag tog mitt Microsoft-konto, men jag är på väg in, så jag vill säga och jag tror att det var så jag ska säga. Let this app access your
Jag undrade, det slog mig
To keep you safe.
Yeah, that's.
Ja, det finns flera att låna av om du behöver.
Ja, hade jag med så det var din.
Oh, it's you.
Yes.
You got the string out there?
Jag tänkte köra ut det och deployen inne, men ja, det kan man ju absolut göra.
Då skulle man kunna finna flera stycken olika portar. Bara skapa en boxning.
Det är ju så. Det är precis att spela upp 100 stycken och plocka dem. Alltså vi kör 100 sektioner. Det vore ju coolt. Det måste alltså, så länge funktionen, så det är det här med template och funktionen måste bete sig på samma sätt. Och jag vet, function versions och sånt kan väl diffa om det körs.
Like I said, I'm horrible at actually finding them. I'm great at looking for things.
I'll see how much.
Nice session.
Yeah, I'm not
Good.
I'm a lazy man. Lazy.
It's always better to have someone else
where
do
you're
it.
lazy.
Exactly.
All of us are lazy. It's just that as long as we combine our forces, we can be lazy everywhere.
But me, the biggest part was I've never actually done more than.
Yeah, I mean, it's just because universal packages är ju bara samma sak. Men då kan du slänga in vad som helst istället. Då behöver jag inte tänka på vilket format eller vilket tagg eller något, utan det är bara så här, ladda ut det. Baksidan är ju, man förlorar lite, man ska jämna och man måste hantera all information för att det blir paket.
Här är det bara så här, ta en zip-fil, ladda upp den, eller ta en katalog, här, nu är det ny. Och så blir den ju bara Azure DevOps specifikt. Ja, det går ju att komma åt den utanför också. Liksom. Det är inte en fil per ett standard.
Men vad det är där, det är så här.
Nej, men det alltså det är som sagt det här paketera allting tillsammans i en bobb och bara så här har du bajset på rummet.
Ja, men då vet jag.
Thanks. Some more tillbaka. Oh yeah, it's just out there.
Still need my book, but I backed up. That with your session, then it's me, not you. I can't make it. What are you talking about?
Security.
Kind of like. Det makes me see something running over.
Yep. Yep.
Otherwise, I can also take them.
Yep.
And
Very
yeah, nobody's allowed. Are you leaving now? Okay, because I'm.
I see.
No.
Yeah,
Yeah, I live out in Tyresö, so I don't want to get salmon.
That with your session. Yeah, it's fun stuff. It takes a bit to get used to, but it's definitely worth it.
I'm very impressed.
The concepts apply to any language.
That's good.
Okay. I don't know how long are you staying in Stockholm?
I'm going to the airport now, so about
Well, have a lovely journey to the airport.
Yes,
I
so
hope you have the best time of your life.
it will be fantastic. I will see reindeers, lingonberries, everything. I'll
You
get
must taste pannagula.
some loot things.
Don't forget the ice bears. They are
Yes.
coming as well.
All right, come here, Matthias.
Ja, starta nu va? Jag ska starta.
Alldeles strax om en minut. Men you see, they will see you in presentation mode. So what we need to do is that
Så jag presenterar på PowerPoint.
I will switch back.
Jo, jag tyckte det var.
Nej, den är här bara för mig.
Då är vi startade.
No one else will.
Go back to the sorry, now.
By the time I get home, no one has one.
Looking forward to it.
Yes. Nej, fick en bad request.
We got lucky with Björn just screen for him.
But it's not a problem.
Let's see what I
It looks good here. Looks good.
My office is just open.
You got my screen on? No, I don't.
Yeah, there's like the shift. So I don't see anyone. So I think all yeah, like the other day, and they
Just have one screen. Don't have a duplicate.
Oh, am I? It's hard for me. Let's do it like this.
I highly appreciate it. I can see trainings once in a while.
What do I present now?
I bring my laptop so you can see.
Oh, yeah. It was good before, and then we did something.
I could do it like this. But I will do something else.
How many screens is it? That's the case. Oh, no, yeah, that's another.
This is usually working. This has been working. I will then do.
I don't know what's the wrong.
I'll do it like då är det så att vi kör. Ja.
She knows some stuff. You can get my.
And I can whisper into your ears.
That would be very awesome.
That would be fun.
Let's see, so if we go up now.
It's Friday.
Okay, that was not the part I was looking for.
I think we're so right. Let's just start over again. Maybe they have it at 2016. 2016 was better in 1 year.
Definitely, that's the case. Definitely.
Yeah.
Jag tror att det är samma hos bara.
Alright, please do not they don't approve this so far. Alright, let's do this.
Yes, come on.
Okay. We're gonna
Sorry,
start the
guys.
next session now.
I had some technical difficulties. This is hard doing a presentation, PowerPoint, and sharing a live stream apparently. So we'll go without notes today. It will be fun. So let me know when we're ready.
I'm good.
You're good.
I'm good.
Sound good. Cool. Hope you guys have got some great coffee and some fika, and I'm glad to be here. Nice. So today we're going to talk about one of my favorite topics, which is security, and that is just a fancy slide for showing off my company. It's for fun. But this is me. I'm Mattias Rudberg. It's my name. I've been working with Azure since 2014, maybe. I've been one of the first people putting API management, logic apps in production. And I've been since 2017. I like to go out and talk like this, blog. So I'm a Microsoft MVP since then. And nowadays I work at a company called DevOps, which works a lot with these questions we're going to handle today. So hopefully you will learn a little bit more. What we do more is that, as we said,
help our team to ship to production with confidence, which can be in many ways, but for us it's security. I would say. A lot of other things as well, but that's what kind of keeps the ball rolling. And when I'm not working, you find me at the gym most of the time. That's where I spend time, or with my kids. That's mainly what I do. So, session today is how's cloud PaaS services changing the way we handle security. There's a long sentence, a complex one, I would say. And in order to kind of grasp the whole idea, I thought that let's go on a journey. Let's go on a story. We need to tell a story to get this right. Because I believe that a lot of things have happened in a way because of we have traversed from on-premise in the beginning and then ended up in the cloud, who came, the savior, and then we ended up today, which is something else, I would say. Because now we've learned a lot on the way. So let's go ahead and take the journey to the cloud. I'm really interested. Oh, look, this was really nice. Sorry, I'm going to go ahead and delete this. You didn't see that one, sorry. I'm going to go ahead and delete that one more. And I'm going to go ahead and delete one more thing. Anyone else has seen my sessions before know that I like the whiteboard, so I don't want to spoil the whiteboard for you guys. That was not fun. Sorry, there was so much technical stuff going on. So let's draw. So I want to start this with kind of like, as we said, we were on-prem when we started this journey. At least when I started developing, I was on-prem, doing stuff there. Was there anyone else started on-prem? No cloud? That's a few. And who has been starting in the cloud? There's a few that are going all the way into cloud. That's fun. And then you might learn some history, maybe. Or you already know it, knew it. But a typical on-prem environment is, I like to draw things. So let's go ahead and draw it like this. We used protection and security was a lot about firewalls and networking. Kind of these high walls. At least when I started, this was the only thing that actually really matters. I mean, even if we were developing things in here, the security around these things was mainly around accessing data in some sort. We were never talking about security as something someone would break into our system. That was really not an issue. The issue we had was who has access to my data. That was actually the thing we did. And whenever we wanted to be public, we had this DMZ part, which is semi-part network, which then we published a website, maybe we published some APIs on it, something for an external actor, maybe AS400 for you guys who have been using that. Some fun stuff. So we could allow traffic in, and then we could, in controlled ways, take the traffic inside our own enterprise. And when we were working at this place, we usually sat on our own network part, at least some companies. So I would have my laptop over here, my desk maybe more or less, and I would be happy coding, shipping things internally. And everything we touched were more or less internal, if no one else said we should go external. This is where we come from. High walls, high security. I mean, the only time as I remember at least, the only time that we really got into security stuff, that was when we did banking transactions. Maybe the salary file going out, that was also, we needed to encrypt that so no one can read it, but that was more of no one can read it rather. But this was our main thing. We had these high walls protecting ourselves. Let's see how this goes now, and I'm going to switch. Okay. So we're in this place, we got high walls, everything is nice. We go into the office, we deliver code, we push everything nice and smooth internally. We have control over servers, we have control over who's connecting to what, who's accessing what. Then suddenly, cloud came. And in the beginning, cloud was mystery maybe. It looked like it was like, oh, what is this? How are we going to use this? And if you go into security and you go into infrastructure people, which we were working really close to, we wanted servers, we needed to order from them. They were really defensive when it came to the cloud. But as soon as we start talking to the cloud vendors, in this case Microsoft, I don't know, the only answer they had was go to cloud. If you asked, hey, I'm going to slow delivery, go to cloud. Hey, I want to scale faster, go to cloud. Hey, I want to build this, go to the cloud. Hey, I want to connect to this, go to the cloud. Everything was cloud. Cloud was like a savior. Every problem you had, cloud was a savior. And the interesting part about this is, anyone working with pre-sale at this time, seeing this chart? Yeah, some nods. That's nice. That's nice. And if you just look at our mindset, so this is on premise. This is where we started. The high walls we saw, networking down here. So that's the primary. What happens, at least as I see it, when cloud came in and they started to say that these are Greeks, we're taking care of this. Our mindset was like, wow, nice. They take care of network. We don't really need to care about it. And when we come into platform as a service, you have seen it today. We've seen functions, we have seen management, we have seen others, and we have always talked about security today. I can say we never talked about security back then when this came up. And I think we were a little bit blinded by this networking part. Because we was like, yeah, we had this. It was done for us. So when we started to exploring cloud, we started exploring it a little bit like a venture, which means that we switch colors. So I can go ahead and draw this. So we kind of started outside of this. We started building our new services to PaaS, even if it was APIs, it was Logic App, websites back at then because functions wasn't really there. We started building them up here. We started connecting. It could be SaaS services. We started connecting these together. We could connect other SaaS services. And obviously we needed to get data on-prem, so we started to install ways to get it on-prem. Either we used like an on-prem data gateway, which has been up discussions, or we used the old school way of getting in. We used old school ways in. Regardless, we were out having a lot of fun. Everything we thought about was like, how do we solve this issue? How do we build this? How do we do this? Which is really nice because it's a fun thing to do. And let's go back. And as we said, we have this green thing here. So when we kind of ended up talking about security, at least from my perspective, that was mainly, again, about data. We didn't really think about security in a way. We thought about security in a way like, how do we authenticate to that service? How do we get data from that SQL? Or how do we get data from that Cosmos? Or how do we get data from that service? That was mainly the thing that we actually talked about. We didn't really discuss security from the developer perspective, from all of the things that we did. It's good to have in mind. And if I look back and look like, how was this time? I think this would explain it best. This is kind of what we did. We tried to do a lot of cool stuff. Oh, sorry. We tried to do it. We kind of were happy we were doing, but in the end, we were playing a playground. We had a full playground of toys and stuff we could do. We just built stuff. We didn't really think about the security part because somewhere along the line, we have been told this is done for us, which made it very easy for us to go. At this point, every service had its own way of handling security. And at this point, static keys was, static keys, everything was like, every service we used, even if it was storage, it was SQL, it was Logic Apps, it was people management, everyone had their own security mechanism. A static key or it could be a SaaS token, which we have was a static key, more or less, but then some sort of easy way of authenticate getting access. That was where we come from. And this was all fun, but as the Cowboys show, maybe it was a little bit too much playground for us in the beginning. And then we had the next phase coming up afterwards, because now infrastructure, security, all of these people actually started to gain insight into what we were doing or what they wanted us to do more or less in the cloud, which means that they started to develop. So our drawing, our environment started to grow. And let's draw this from up here. So they started in parallel very often. So they started getting up, starting express route maybe, started building up network structures inside of Azure for any other cloud services, and they started building up, deploying their services in there. And they also started looking at us as the black sheep because we were having fun on the side. So they wanted to kind of force us, so they started building up network structures for us as well. That was actually a good thing, but maybe not always the best communicated, but it was a good thing. So they wanted us to kind of get into that strict area of networking, which is not very strange because that's where they come from. Networking is important. It's important to have that lockdown. This obviously comes with its problems, but this was the phase that we ended up in after a while. So then we could start building our services in here. You have seen how networking has evolved a lot. And if I look at this part, we had infrastructure helping us out with networking, and we could deploy things in this. We could actually start talking about security, but it was still network. Still network. So that was the next phase. The thing is that a bit after this phase, things started to happen as well. And one of the things that I think was well, maybe the biggest driver in some areas is the Cosmos, the Chaos DB, as we call it, the Cosmos DB incident, where an attacker, a hacker, could get any key from Cosmos DB via Jupyter without actually having access. Why could they do that? Yeah, because they had a bug. Microsoft released a bug in here, and in the end, we used static keys here. So when that static key wandered away, they could get access to it. Obviously, this was not a problem if the thing was in network. So the network infra guys, they got a good hold on us. We didn't really want network. They actually got a good one on us. But the thing is here is that things can happen. And we need to kind of understand the mechanisms and things we're using. This happened because static keys was there. That is the reason. So at this point, we have heard managed entities during the day, but that is for anyone who wants to understand it a little bit, I like to draw it. Let's do that because I like to draw. So what they did was introduce these managed entities, which is more or less a virtualization of a user in AD. So let's just go ahead and say AAD. And this is ML, and this is me. So this is me in AD. And if I deploy a logic app, for instance, I can then create an entity inside of AD, which is that logic app. And due to this, I can then, exactly as I do with my own user, I can add permissions. So I can start giving permissions to me or the logic app. Another good part is that I don't have to understand anything about how they authenticate or what client ID, client secret name. I can't even get a hold of it, which is just the same as me as a user. An AD admin can't get my username and password, or maybe username and password. That would be tough. That's the same principle. So static keys and managed entities, the managed entities started to take over. Managed entities got a really boost from Microsoft the fall after that. They really invested heavily in this because they saw that the critical part of having static keys. So if you look at many of these resources today, you're able to use role-based access or even later attribute-based access. And this is really something very beautiful for us because it kind of removes a lot of our headaches. It's making it easier and it's making everything more secure as well. So just a short one on role-based access. So this is different roles, users and, as I said, managed entities. And then you kind of have a role definition, which is some sort of access. Could be owner. That's a fun one, right? I remember the days when you had owner. That was good old days. Nowadays, it's always contributor. They're mean today. And then you put it on a scope, and then you can put it either on a management group or all the way down to a specific resource, which means that we can grant very granular access, which is really good because we should really work with least access. That is important. Then, let's move that sharing your screen stuff. If we want to look at the attributes-based access control, that is a combination of the role. You need to have the role. So Chandra here have the storage blob data reader role, but she then also has a condition. So a specific tag, project cascade, is she able to see. If you look at that storage account that she actually has this access on, you can see that she can only access files that has this tag. She's not able to get those files, but you can get those. This gives us even more granular control over what the person has access to. This is awesome, right? Now we can skim it down. And this is things that infrastructure and the owners nowadays of Azure subscription does, because they really want us to have so little revenues. And it's good, because that gives also a bit of responsibility from us away. Because to be honest, having a lot of responsibilities, having a lot of these things, an owner role is actually not really good, because you can do a lot of damage with an owner role if you are evil or get hacked. Somewhere around here, they also started communicating a little bit different. So this is actually the same slide from Microsoft, but a little bit different. As you can see, this is not green anymore. That's the biggest part. But also, they introduced physical hosts, physical network, physical data centers. Because that's what they actually meant. The networking before wasn't the networking around our resources, it was networking around the data centers they were talking about. But this is a big difference in communication. Much easier to understand that I'm actually part of network controls. So me, as a developer, I'm actually part of that network controls. Or if I have an infrastructure person help me, or a DevOps engineer maybe, can help me out. But we need to understand that we are a network, application, identity, directory, and account of entities, devices, and at the top, information and data, which previously was the only one we need to care about in the communication. This is important difference. This is something that we need to understand when we do things. We are so much responsible for this. Like the Cosmos DB incident. We could have put this on network, or we could have working with rotating keys. By the way, how many of you actually have done a rotating key solution? Oh, there are a few. Nice. And it didn't break? Oh, even better. Nice. Good one. That's good. But we need to take bigger responsibilities of what we're doing, because it's important from a developer perspective to have that, or from the whole solution perspective. As I said before, we got this communication, and now we're having this communication. Big difference, a big mindset change for us. And that's important. We cannot just chip code and be happy. We have had sessions today with code, chip happy. We have sessions talking about security. We've been talking now, security again. It's fun. And then we talked about testing, which is even more fun. So we need to have an increased understanding of security as a developer. We need to understand what we actually are doing when we are publishing these things. Because we are publishing things. As we saw, we are building biceps. We're publishing things out there. And we went from high walls, a protected area, where we put something in there. I mean, the only villain there was my neighbor who was like, I want to crack your solution. But nowadays, we're putting things out public in the cloud, most of it. A lot of services are still public in some sort. And if you think that no one is understanding that they're there, you should try to put up a VM and expose an HTTP service or an FTP service of some sort. And then you should look at the logs, because they are like with attempts. So people are noticing what you're publishing there. Be aware of that. Oh, back to coding. Nice. So, what do we mean by this? Yeah, it's that even if we are deploying into this lovely environment that network guys put up, we probably will use resources outside. We probably will connect in some way with other resources over here. It connects to other resources somewhere. And it's so easy to forget about this. Because even if you do some of these network parts, like we saw the private endpoint thing, like you connect this to this network, they might still be accessible outside, from outside. Maybe it doesn't matter, but why should it be accessible if it's not supposed to be? Things like that needs to be in calculations. And even worse is the one that we saw with API, where you are building up this huge, I've seen this a lot, application gateway for management, and then you put up a function, consumption in the cloud, and the only actually security mechanism is that function code. We'll spend so much time on building the front, because we're used to the front is the only thing that matters. We forget the services part. Important thing to keep in mind, and it's actually many times we as developers who control where this comes, what properties are set when we do this release. So keep that in mind. As we said, responsibilities. Every time we do infrastructure as code, we have a lot of responsibilities. We have a lot of fun as well, right? Yeah, but we also have responsibilities, because things we are chipping out goes out. So just to emphasize that a little bit, I found this yesterday when I was looking up things. It says hospitality here, but it's actually a hotel. I don't know why I did hospitality, but I copied it from that report down there, the data breach report. But this is a hotel chain from Spain, or Spanish company who actually had this. They accidentally did some misconfiguration. It was an S3 bucket, which is much more fun to show in Azure. Accidentally misconfiguration, and people got stolen about 10 million files. Do you even know what the cost of that is? It's like huge amount of numbers. I don't know. They have a number for each file that is leaked, and it's like 300 something. When you take 300 something times 10 million, you start getting huge numbers to actually calculate what the loss is. And this is dangerous. Not only can we get the keys stolen from us, we can also get this misconfiguration. So all in all, it's a mindset change. We need to be more cautious about what we do when we do development. When we handle securities, what type of securities we put up on our resources that we're using. It's important. Because take another scenario. I work here on my computer, and I work to my, let's say put the Cosmos again, and I have that static key on my computer. And it's easy for me to debug. Everything is nice. I can do it here. It's nice. What happens when I have a friend over here who's going to work with it as well? We need that connection as well. Well, obviously I share that secret with him because he needs it to be able to work. But how do we share it? We send it by email. Do we check it in by code? Big no. Or how do we share it? Do they get to download it themselves? How do we do it? We need to start understanding how we share this all over the place. And if you're a consultant like I've been, if I leave that customer, where's that key? Is it still on my laptop when I leave? Probably, some sort. But if we switch to role-based access, so it's my AD account that is used, I don't need that key. And when my friend needs access, we need to grant him access permissions in the AD that's visible. Someone knows that he has access. And when I quit that job, I go and walk that way. They kill my AD account and there's no access left. So we need to understand how we handle security, both from the developers and not. Because this is actually rather tough one. Gartner says that 99% of cloud security failures will be customer's fault, not the vendor. And by customer fault, they mean infrastructure. Anyone actually who handles infrastructure as code, to be honest. Or you could be social engineered, like people at Uber. Uber actually had quite a nice setup, if I'm not mistaken. That's the information I had. What happened? Have you heard about the Uber breach? No. Okay, so you don't have cool. Then I can lie. Perfect. You will believe me anyway. That's nice. No, but so what happened was Uber using cloud, they're using Amazon, I think. Doesn't really matter, cloud. So there was a hacker. He social engineered one of the developers. So he social engineered his developer. He stole his VPN credentials and logged in to their. Let's go ahead. Let's pro again because it's much more fun, much more visual. So let's go ahead and let's add this developer here for like it. So it doesn't really matter if you go to cloud or if you go to on-prem. Doesn't really matter. But let's say we have an orange arrow here, which is the VPN, and hacker stole it. So he stole this VPN. Now I brought it on-prem, but it probably wouldn't be cloud, but you get the point. The thing is, okay, so it's inside. But they have been pretty good at doing stuff, locking it down. But what do a hacker do when they get inside? They start looking for secrets. They start looking for things that they can use. You know what they found? On this particular server over here, let's use another color. Let's use that. On this server here, there was a tiny little file. It was a PowerShell script with credentials from an admin stored on the machine because they needed to run it concurrently. Small file hidden somewhere. But by scanning with tooling, it's easy to find. And he found it, and he took over the whole thing. He took everything. He took over the AD or whatever they used, and then he took over Slack, he took over everything. It was game over for Uber. Just because one person accidentally stored a PowerShell script with credentials on a safe server that then got exploited and hacked. So be very, very, very careful where you store credentials or files with keys in some sort. Because if someone comes in, they will find it. I promise you. Okay, but we shouldn't put ourselves down that much, right? We need to kind of work against it, right? I just want to scare you a bit because that's much more fun. So how do we get to some sort of status where we're working with this, against this, working to our good, better progress? Well, we should always get a requirement of what we have. How many of you are consultants? That's a big bunch. How many of you have actually gotten security requirements handed over to you when you started to work somewhere? A little bit at least. Not every time, I guess. But it has happened for a few of you, like 5% of all of you have put up hands. it's so seldom talked about that it's actually a bit scary. Because we are talking about we want high security, but we never talk about what it is. We need to start about requirements. What is actually requirements on me when I come in, or on the team, or on the company? What is requirements? And then, regardless of where you are, you need to find some sort of compliance level, because all requirements might not be feasible in the end. You need to find somewhere where we are. How do I get there? So I need to understand. And then we need to start implement, and we need to put up guidelines, stuff like that, to get everything rolling. And the last part is following up. Because what happens when the project screams at you? You don't really follow the guidelines, do you? Sometimes maybe, but not always. It's easy to skip 1 or 2 steps. So that's why we need a follow-up part. I took this from well-architected framework, because I think this is a nice one, actually. This is a nice process they have. So there are a lot of talks about it, but it's like first you plan and develop, and then you commit the code. Or, as we said, this is more like requirements. It's a little bit like getting up there, know what to do. And then you go to build and test. So every time you go build and test, you should dynamic application security testing. Interesting. Cloud configuration and validation. Anyone does that? I saw a beta test this morning, did something at least, a tag, which is not security, by the way. Infrastructure scanning. You need to understand how the situation is. And then security acceptance testing. These are steps that we should take when we're in a building. And I know that these are not easy, but they are there. When we go to production, security smoke tests might be done somewhere. Configuration checks. Have you actually checked your configuration in production any time? Infrastructure as code is nice. It's really good. You can make sure that it's up there. But what's actually production? And then, obviously, over time, we need to understand this. There are, of course, help in this, because this is a big topic. It's not just us developers. We are part of it. There's a lot of other people as well. We get infrastructure, we get security. And if you want to work with these processes, like getting help doing this, there are some ways of doing it. And some toolings that you can use is Azure Advisory, which is a free service that is available every time you go into the Azure portal. Every time you go into a resource, you will get this small advice. It's high and low, I would say. Sometimes they're really cool advices, and sometimes they don't have anything. It's a bit like that. After that, we have Azure Defender. They work a lot with networking, a lot of file checks. They come from Defender side, which is a antivirus system, but they are growing like crazy in other areas as well. So they are building up, checking, as I said, the networking, malicious stuff for that. It's also checking some of the configurations as well that we are talking about here. And it's also doing files on a lot of things, like installing agents and servers and stuff like that. Then if you use infrastructure as code, which I hope you do, you all do that, right? Then we can use some scanning tools to get an idea of how we're doing. Then we'll find different configurations, or even we could create our own stuff with that tool we saw this morning, for instance. And then we come in. Helium is our product, which is where we kind of developed this because we found a gap on the market. Because this is really hard to do on a deeper level for PaaS services, especially. Because what we lack is a constant level of consistency over all services, and we also lack the deep knowledge. Because Azure Defender and Azure Advisory, unfortunately, has a very shallow, the knowledge into different resources. So this is toolings you can use to get on board this, and even verify over time, because we need to do this constantly. This is not a one-thing job. So the yearly review thing you might be working with, that should be increased a lot. I don't think Hacker waits for yearly review. And if we're going to go and put some takeaways, on this. I would say the most important part is to understand from our perspective as developers, as architects, as DevOps engineer, or I don't know what role you have, what responsibility we have when we publish something. What do we have as responsible for this API? What is the requirement on me? How do I do this? Do we have the skill set to actually understand this? Do we as a team have the right skill set to do it? We need to understand that. And that's harder than you think, to be honest. But take responsibility for what you publish. Then we also need to have some other teams as well. We need some good support from infrastructure. Because to be honest, I said that networking was the primary security mechanism back in the days. But I have never worked so much with network as I've done until I moved to cloud. It's network all over the place. You need to understand network more than ever. So take help from infra and security because you need to understand what you're doing when you're opening your network security groups or whatever you work with. And security is a team sport. That's important. And if you want to take actions, start and actually understand what is your requirement on your team, on your organization in this area when it comes to security. And also make sure that everything we do should be good. We need to have a process for that, making sure that we actually validate what we're doing so we don't put up more stuff that we need to take care of and fix over time. And I think that's about it for me. Any questions? No thoughts at all. So all this security talk and all this stuff and no one has anything. Oh, Jonas.
Why is everyone trying to build on-prem solutions in the cloud?
So the question is, why is everybody trying to build on-premise solutions in the cloud? Well, if I would have an answer on that, that would have been nice. But my best guess would be because it's what they understand. It's easier because we have always been there doing that. Any more thoughts? Yes.
Would you invest in more teaching the developers about security, or would you split it by letting them doing what they do and then putting someone else to control it? Just in terms of where the investment should go.
So the question is, should I invest in educating my developers on security, or should I more or less have a more centralized piece for security? Is that correct? So I would say both, in a way. We need to have it centralized because there's a big picture to have. But the security is also very important for developers there. Because as we said, we are publishing things public in many cases. Not always, but in many cases we are. And we could easily do wrong and publish it, a non-public thing, public. So we need to have better education, I would say, for developers than we have today. Because in many cases, it's just like, hey, do that, it's good for you. More questions? No. Then I say thank you very much.
Jag vet inte, du kanske inte är en sån som snubblar. Men jag sitter här och tittar och kollar. Så snart händer det. Nu vet jag när det där.
Is it time to start?
It's indeed
It is
time.
time to start. Please take your seats.
Please take your seats.
Var det mitt glas?
No, I don't have glass. I usually don't drink. I'll stop doing that. So according to information, I'm the last person between, well, the beer, the drinks and foods and stuff like that. So I will try to make this in 5 minutes so you can be really short about me. My name is Michael. I've been a Microsoft MVP for since 2005, many years. I work currently on TrueSec with the Cyber Incident Response Team, which means that people call us, we answer and say, hey, we have a crisis situation. And then we solve that, which means that I see things that nobody should see. And I've seen things that I couldn't believe it existed, but it did. I'm really old. I started out with ABC80, Sinclair, Spectrum, Commodore 128, Amiga 2000, and I have actively worked with 8-inch floppies. They are really good when it's hot. Otherwise, they are useless. You can store 160 kilobytes of data on a floppy that is 8-inch in size. So one thing that Microsoft have been missing for many years is the ability to manage servers. They really never had that. According to information, when you look around customers, how they are working with the server, we can see that. We can see that in the incident because we do inventory. So we can see that the number of interactive logons to servers over a year is 239,000. And number of logons using remote PowerShell is 5. That indicates something. It indicates that people are using remote desktop protocol, RDP. They click on the server, they do stuff on the server, they click on the server and do things interactively. And if you go back to the year 2000, anybody remember that year? Nope. Okay, so in the year 2000, Microsoft releases remote desktop for administrative purpose. And the first thing they said in the documentation was, do not use this unless it's an emergency situation. You should always use the remote server admin tools. Yeah, but just clicking, that's awesome. It was intended for users and never administrators. Azure Arc is a collective name of multiple things. One of them being the Azure Arc agent that has nothing to do with the bridge. It's really two completely separated items. The agent is intended to run locally on a Windows server. So you can use Azure as the control plane, meaning that you authenticate against Azure with your proper credentials using multi-factor authentication. And from Azure, you manage your on-prem servers. Now you can actually do remote desktop connection if you connect using a local administrator account and not the domain admin account. Then it's fine. You can restart, you can patch them, you can do all that stuff, right? That's Azure Arc Agent. The bridge is the opposite around, kind of. It's different. The Azure Arc Agent, we will spend a few minutes just talking about that, is what we try to convince all the customers that I work with to have. It needs to have a proper configuration in Azure, otherwise it's going to be dangerous. It's controlled by resource groups, And if you put all the servers in one resource group, anyone with access to the resource group is a local admin everywhere. You just reinvented the who. It uses a bunch of extensions. It's pretty neat. The Azure Arc Bridge is, however, something else. It is a link between Azure and on-prem. And I really meet people that really believes that everybody's going to run everything in the cloud. There will no servers at all, no desktops. No, I just connect to the cloud. I really meet people that believe that. I don't. I see customers still running Windows XP, and they do that because it's a part of manufacturing, and that part of manufacturing is old. But the lifetime of something that manufactures a bed is like 50 years or so, so they don't change every time. Running VMs is possible to do in Azure, in Amazon, and all that stuff, and you already know that. But the cost-effective way to do it is run it on-prem. That's why Microsoft was forced to rename Hyper-V to Azure Stack, so that people go like, well, I'm moving to Azure. Yeah, Azure. It's on-prem. It's Azure on-prem. It's called Azure. Yes, check it. The problem is that if you do that, you have one way to manage your systems in Azure, and you have a completely different way to manage your service on-prem, right? It's not even close to being the same way. It works with VMware Hyper-V and Azure Stack. It is a Kubernetes cluster that runs in a VM, which runs an extremely weird operating system. And the licensing is free. It's intended to be free. It will most likely continue to be free, because this is something that I define as an enabler. If you have this, you have the option to buy other things within the Azure subscription system. If you don't have this, you can't buy the other stuff. So this is like, here's a free entrance card to this store. Great, the card is free. Yes, inside the store you can buy anything. Azure Arc Agent. Anybody tried to install the Azure Arc Agent? Did it work? Was it complicated?
No.
Did you? Did it take a long time for the agent to report?
Not really.
Exactly. It's extremely fast, right? It's usually within a minute or so. And it really pops up. It can use public connections, but it can also use private connection. It can also be behind the proxy. So it's easy to make it work and to connect. The only issue you have is that you can't put everything in one resource group, because then it becomes dangerous. And you really need to have the proper security configuration in Azure. It can't be a next tenant, otherwise it's going to be dangerous. It's always outbound connections, but it does have listening ports inside the tunnel. So it connects out, but when you are in Azure, you connect through the tunnel back, and then you define what port should be open internally. You charge when the machine is connected and not when it's not connected. You can connect both on-prem VMs as well as Azure VMs, and a bunch of other things as well. We're going to look at that later on. The Azure Arc Bridge, however, it's a VM. It runs something called CBL Mariner 2.0. Anybody knows what CBL Mariner 2.0 is? That's Microsoft's Linux distribution. It's their own distribution. Anybody knows why it's named Mariner? Seattle Mariners. That little team they have over there. It's a lightweight operating system. It's the only reason why Microsoft owns it or controls it is because exactly that. They need to control. They need to make sure it is updated so it fits anything else in Azure. They need to control release states. They need to control release updates and patches. It can't really be used for anything else than things that Microsoft would like you to use it for. But it is a Linux distribution. So you have your VMware environment at home, or you have your Hyper-V or Azure Stack or whatever, you install this. This runs as a VM in your environment. It is an extended connection from Azure. So this one connects back to Azure, and in that tunnel, Azure connects back to whatever you run, right? The weird thing, and the part that people don't really understand, is that how do I connect it to VMware? What versions of VM does it support? How do I connect it to Virtual Machine Manager or Azure Stack? What version? How do I install the agent? There is no agent at all. There's nothing to install. This VM is using open API connections. So if you connect it to Azure Stack, it's using remote PowerShell commands to connect to your Azure Stack environment. If you use VMware, it's using the open API that you have in vCenter. It's just using native functionality within. Therefore, it works with anything that is supported. So even if this is new, it works with older versions of VMware, and it works with older versions of System Center Virtual Machine Manager as well. You can go all the way back to System Center Virtual Machine Manager 2016. I haven't tried 2012 R2. I'm pretty sure it's going to work with that too, because it's the same API. And this is also good for the future. It means that just because you're upgrading to a new vSphere or a new, you're upgrading your on-prem stuff, it doesn't mean you need to adjust anything or do anything. It just works. We need a VM for this. I have one here. Here I have. Like. We can go here. Here we can go. So in Azure Arc, on the left side, you have all the settings here. Can you see the screen? You have all the settings here, and usually servers are here. Here's the servers you have. These are the servers that have an agent installed on them. I don't have anyone right now, but if I had Azure VMs, I would see them as well as here as well, right? I don't need to install an agent on them because that agent is automatically just deployed when the machines are installed. But what we're going to look on is this. These VMs runs not in Azure. All these VMs runs on-prem. That means that I can have my own custom locations. So for each and every bridge you set up, you have a location. So you basically generate New York, Stockholm, Örkelljunga, Uppsala, or my garage at home as a location. A location is just a location, but you can see here I have 2 Azure Stack solutions and a System Center Virtual Machine Manager bridge. Adding a location is not really complicated. You define that you have a location. It's tied to subscriptions, resource group, and then you define it as whatever Arc-enabled service you have. When you build this, it will ask you for the location. So you always have a default location, which is kind of easy. It uses these systems You can see that I actually have two of them. They also have two versions. This is the preview right now, right? And previews means you need to work a bit. There are no automatic updates here. If there's a new version of the bridge, you need to redeploy the bridge. I'm going to tell you immediately that this is a trick. Nobody told you about this. When you first deploy this, you do that from one machine. Your whatever machine you have. It's going to be your privileged access workstation, your shared jump station, something. There's an option when you deploy this to specify a temporary folder. In that temporary folder, the entire configuration will be stored, including the keys to access the resource bridge. Remember that folder. Keep that folder. If you need to reinstall this, the only thing you need to do is throw it away, run the script again with a switch, reinstall. Then it will download a new image and do the same configuration again, because the configuration is actually stored in Azure. So the bridge itself is just a dummy. It's just a command converter, right? So is it really scary if I throw it away? No, it takes about 40 minutes to build a new one. If you don't keep that little folder, then you need to do it all over again. Fill out the form, specify all the accounts, specify all the grid numbers, subscription ID, phone number, shoe size, and all the other stuff. So nobody told you, there's no documentation that says this, but if you read upon how to recover, how to connect, how to troubleshoot, all that documentation says, well, from the machine that you did the last installation, it will contain all the keys and all the configuration items. So as long as you keep that, there's no issue. So keep it. They will change this because it's going to be possible to automatically do this, but right now it's not. So this one is the oldest one we have. And you see, there's nothing to it. It's just an entry in Azure, more or less. If I want to build a new VM, I create a new virtual machine. And it's going to look pretty much like building any kind of VMs. It's just that I defined my subscription. As you can see here, I have 3 different subscriptions. You should put all these self-service functions in a separate subscription for security reasons. It's possible to run them in the same, but you shouldn't. So all self-service items are in a separate subscription. Then you need to pick the location. In my case, I can pick that location, and that is automatically telling me that that's a System Center Virtual Machine Manager environment. If I select that one, instead I get an Azure Stack HCI. So you can either run this directly to Azure Stack HCI if you want to, or to System Center Virtual Machine Manager. If I had a third location, that location could have been the VMware environment, but we haven't connected that yet. But it's going to be the same thing. And the process of building VMs doesn't change. So in this case, we're going to pick that one. I want to have an ability set. I want to use a template here. Oops, sorry. Not bad. Shouldn't do that. The number of templates here, we're going to talk about that in a few minutes, but you publish your templates. You publish your network. you publish that to resource groups. So this basically works like this. All the permissions are handled by resource groups. Who can create an object in the resource group? You can see the network that you have assigned to different resource groups. So think about resource groups like a file system. That makes it easier. If you do this incorrectly, it's going to end up in the everyone can build anything everywhere, anyhow, anytime. I'm pretty sure you don't want to have that. That's the usual way it looks like in Azure when people can build VMs. Anyone can do anything everywhere. Great. Let's define an account. Most likely I'm going to need to do this twice. Apparently you need to have the same password in both of these dialog boxes. Thank you. Disks. I have the ability to, like any kind of building VMs, pick disk, select disk, change disk, connect disk, edit disk. Same goes for networking. Any network I have the ability or the right to see, I can pick and choose. I can check that box. I can give it tags. I just need to make sure we have a name of this machine. That's the wrong name. Much better. If you so wish, you can of course download this as an ARM template, modify the template, do whatever you like with the template, deploy it using a template, or using PowerShell, or like any other resource you have in Azure, you can work with this. The location properties we're coming. Sorry. Why does live demo always suck when you do it incorrectly? Sorry. Need to have it here. Seems better. So let's take a peek look. And I talked about the Azure Arc agent, the one that you have installed. In this case, I have a server here, and the server is our management server. It does have the Azure Arc agent installed, and therefore I can, of course, use Windows Admin Center from Azure to connect to the on-prem server without having any VPN or remote desktop gateway or anything. I just connect directly to the machine. It's pretty convenient. Remotely manage on-prem systems without having any kind of network connection, because all the connections is outbound. And since Windows Admin Center is installed locally on the machine, I can now use remote desktop to connect to the machine. You can even run SSH. Did you try that?
No.
Okay, because that's pretty cool too. And if you do run SSH, there's a little trick. I can't show you that right now, but there's a little trick where you can run RDP through the SSH tunnel directly down to the VM if you have PowerShell 7. And that means that you can just connect to any machine from anywhere using SSH. That's like, isn't that like hackers do? Isn't that exactly what they do? Yes, they do. It's just is that we do it legal. We do it authenticated. And we do it because it's a very nice way to be able to be anywhere, authenticated correctly, multi-factor authentication, you belong to the right group, etc., 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 without exposing your on-prem systems. Today, what we see when people are working remotely is that the external consultant needs to work on this customer. The external consultant gets a VPN account. The external consultant takes his laptop and virtually connect to the customer's network. Really? You're allowing a consultant that you know works for 600 other customers to take his dirty laptop and plug it into your data center. And if you're a consultant, I don't dare do that. I have no idea what's on the other side. There's no reason to connect my laptop. I'm pretty sure that none of you will allow me to walk into your data center and go like, well, the servers are over there. You know, you can pee in the corner. It's fine. It's, you know, go into this. Nobody allows that. But remotely connecting anything from anywhere, that's fine. Now do it done like this is better. Okay, so I minimize that. And let's see if we have a job running here. And maybe we have. Or is it done? Did I blew up this demo as well? Job failed. Because of prevented deployment that must be resolved. Oh, God. Yeah, it did fail. I love these error messages. Configuration issues related to the virtual machines. Prevented deployment. Needs to be solved. An error has occurred. Fix it. Okay. And let's find it first because I need to remove this. Okay. Let's go to the resource groups. Over here. Good. Bye. Back here again. Great. Self-service, resource group. Hooray. I can go back again and see how to do it. So, should be running here. History. Please show up. Yeah. So if I go into System Center Virtual Machine Manager and see who's doing this, it's just a service account that is working. And it's logging on and it's working with the systems, and I did something wrong this time too. Why did I do that? I have to be stupid. I hate live demos. But we can't spend more time on that. The trick to control who can and who can't is, of course, permissions on the resource groups. But the big problem we have is this. It's called challenge. This is a logical representation of the System Center Virtual Machine Manager server that we run on-prem. If you do VMware or Azure Stack, you have the same. It's just a placeholder. If we go here, you can see all the different clouds that we have. I need to go back here because I need to make sure that we have all the clouds collected. Right? Okay, go back. Here we are. VM networks. So all the networks that we would like to publish, that users should or administrators should be able to use, we need to pick and choose them. So I have them in either VMware, or I have them in Azure Stack, or I have them in VMM. Pick and choose. This is published. As you can see here, they are published to different resource groups for different purposes. Same goes for templates. So I have a lot of templates, but we didn't publish all of them. We published 2 of them actually. You can only see one of them because I have more pages. But you pick them and say, this goes to this resource group. That means that we could, and we have done that, we publish all the templates to one resource group. It's a read-only resource group. So regardless of where you can store your VMs, you can always read from that resource group. So we just use that as a publishing resource group to put the whatever object we want them to be able to pick and choose. You can define clouds if you want to do that, and you can also pick and choose virtual machines. So even if you have them and they wasn't built that way, you can, after they've been built, you can publish them. You can also say, if you build them using Azure Arc Bridge, we can remove them. So it's a pick and choose. Anything you built using Azure Arc will be published automatically. Anything you don't will not, but that can be flipped in either direction if you so wish to. So if you go to virtual machines, you can see that we have, here, a bunch of them. So why do we use this? Because we actually do use this. We build a lot of VMs. Many VMs. They run heavy for a short while. We use them for parsing, for decoding, for cracking, all kinds of stuff. I can run that in Azure. I just can't afford it. Because the price of those disks that we need to have in Azure, the cost for them is too expensive per second. It's just, I can buy 10 laptops a day and that will still be cheaper. So it's about a tenth of the cost to run it on-prem, including hardware, licensing, and all that stuff. It doesn't matter. It's just too expensive to run fast VMs in Azure. It wasn't intended to. You can run Azure VMs, of course. It's not a problem. It wasn't designed to be fast or cheap. It just is a possibility. So we use it for this, which means that most of this is automated. When we have things coming in, could be an incident, we automatically spin up or build around 20 VMs for different purposes. And when we are done with that security incident, they are thrown away. And of course, we can do that in Azure, but that means it's going to be too expensive. We also have a problem with GDPR and security and storage of data. There are a couple of Swedish organizations and companies that really doesn't like that we store their data in Azure, so we need to store it locally. But this doesn't store data anywhere. For VMware, it's the same story. for Azure Stack HCI, it's almost the same story. It's close. There's a difference here. If I run anything on System Center Virtual Machine Manager and Hyper-V, it's just Hyper-V, right? It's just nothing fancy. But if I run it here on an Azure Stack HCI, it's suddenly Azure. All the licensing is Azure. All the feature set is Azure. Because if you read on the screen, it says I can use Azure Virtual Desktop. I can run Azure Virtual Desktop on-prem. I can run Azure Edition of Windows Server 2022. I have the extended support for Windows Server 2008 R2 because I run Azure. This is really running Azure on-prem. So the only thing I need to do is hit deploy over here, and then I have Azure Virtual Desktop on-prem. Do you think that's going to be cheaper than to run Azure Virtual Desktop in Azure? Yeah. Somewhere between a third of the cost. You still need hardware. So you need to pay for hardware, right? But it's still going to be cheaper. You also have auto manage if you want to do that. And you have all the other extensions and connections as well. It's just, this is Azure on-prem with all the rules that applies in Azure, but at home. You know why they named it Azure Stack? I told you that before, right? But they really did, because I talked to the product team and said, we have a hard time explaining for customers that they shouldn't run VMs in Azure. They're just consuming our really precious data center with garbage. Yes. So what's your plan? We're planning to rename on-prem systems with the name of Azure, because that means that people think they run Azure. Does it work? Yes. Great. I was kidding. But that's basically the idea. Let's go back to the slide. There's a couple of things that you need to have. It takes about 45 minutes to set this up, regardless if you do VMware or Azure Stack or VMM. The download is, I don't know, 10, 15 minutes, something like that, but it needs to be configured, and that takes time. It's also the Swedish definition of it. It's like spaghetti code, because it starts with PowerShell, and then it flips into something else, and then it goes back again. So it's not one script, it's just a bunch of different scripts written in different languages that are chaining into each other. And you are going to say, I'm the administrator at least 5 times. This is a preview, right? It will be different. But right now, it's working. It's working good. It can be used, but it will be better. There's a couple of things that you need to understand. You need to have a bunch of IP addresses. This is a Kubernetes cluster. It's using IP addresses for the control plane. It's using IP addresses for the functions inside. It also needs a range of IP addresses. Usually DHCP or something like that works fine, but it needs to have that, otherwise it doesn't work. In the end, the darn script is going to ask you something like that, like this. please enter your administrator credentials for whatever server it is. Those credentials will be the ones that are used to do all the work for the rest of your life. That's not your administrator account. That's not your domain admin account. That is your tested service account. It is an account that you can use to connect to VMware or to VMM. And when you do, you can build VMs. That's basically what it needs to be. But it asks for, please enter your administrator credentials. I did that a couple of times. Like, no. It will ask you to be highly available. According to Microsoft documentation, this must be highly available. It does not work if it's not highly available. But when we install it, it says, would you like me to be highly available? No. Okay. It's just a VM. If you want to do it highly available, put it on a highly available system. It really doesn't matter. It's just a VM. And it stores all the configuration in a temp folder that you're using. So let's go back here and I will show you how it works. And where are we? We are here. I think we're here. Here we are. Let's find this guy over here. That's really neat to be able to copy and paste through a web page that is running remote desktop connection in an HTML5 window. Here's my folder. The Azure Resource Bridge 2, ARB2. This folder contains the keys and the entire configuration for your Azure Bridge. And this is the folder you need to keep to be able to reinstall it, to be able to reconfigure it. And when you need to have the log files, it's going to say, oh, you need to have the SSH keys. What? I didn't have any. No, they were created when you set it up. On what VM did I do that? Anybody have that feeling when you go like, I remember I did that on a VM somewhere here. I think I have the files in a folder somewhere. Let me spend 6 hours logging on to everything I have and try to find the files. Nobody? It's the only me? Just checking. Repeat. You use resource groups to create security boundaries. You publish networks to resource group. You publish templates to resource group. Clouds and VMs, everything is published to resource groups. So you need to create a resource group hierarchy or a group configuration. If you want to do proof of concept, you can put everything in one location. Proof of concept is a great way for threat actors to get into systems. So please remove all the proof of concepts when you're done, because it's usually made like that. We have seen bad people go like, oh, it's great. You can install the Azure Arc agent on everything, and they download the script and they do that for everything. And then so the domain controllers are also Azure Arc agent and an authenticated user in Azure, and guests can log on to each machine. It's great. It's fantastic. We now have 16 million domain admins around the globe. So be careful when you do this. If you do a proof of concept, make sure that you actually do this. Nobody have access until you're a member of the group that does have access. There are built RBAC rules for this. Use them. They're not perfect, but they work fairly okay. But you don't need to be global admin to do things like that. For doing things like this. Deploying the bridge, it's easier than you think. Yet it's complicated. Let's go back here again. And let's go to here. It's add your infrastructure for free. Thank you very much. Servers, platform. You're looking for platform.
Okay.
And you can see that you have the three platforms I talked about, right? The VMware, the System Center, and the Azure Stack. There's no box here for Azure Stack. And that is because that is automatically built when you set up Azure Stack. It's a checkbox when you set up an Azure Stack environment. Yes, I would like to have an Azure Arc Bridge because that is also automatically registered as a function within Azure. Therefore, you can't add it here. But I can do it here or here. And if I do it here, it generates a script. Now, the interesting thing is here, says that you can either create a new resource bridge or you can use an existing one. What? Yeah, you can have one. And that one can be used both for Azure Stack, Virtual Machine Manager, and VMware. It's just one VM. It doesn't have any agent. It just runs code, right? So it can be anything. You can have multiple if you want to have. And the primary reason to have multiple is that you don't want to have a connection between your VMware and your Hyper-V environment. It's two different solutions, right? You want to have them in two different locations. Even if you, in theory, could have, one location and say planet is the location. Maybe you want to have multiple, but you can reuse them. But I want to say new, just for the fun of it. You define the name. You define the location. You define the resource group because you need to have one. And the region. As you can see, there's only two regions to choose from. Here, you're going to create your custom location. So you don't need to go into custom location after you're done because you already have a custom location, the one you created when you created the bridge. So you can use the same. You also need to give, in this case, the virtual machine manager, some kind of fake name. My SCVMM server, or whatever that is. And then you do tags. And we need to have a custom location. Let's call it demo. Sorry, demo location 001. Happy now? Thank you. And then you download and run script. And this script contains all the things we want to have. Now, the interesting thing here is that you can either run this script on a Windows machine, but you can also run it on a Linux machine. Doesn't really matter. Just building a VM. I have tried it on a Linux machine. I can say from the bottom of my heart, it's I think it's more tested on the Windows platform. But it works. This script does everything. It downloads the new image, installs the image, builds the VM, configure the VM, connect it to Azure, register it in Azure. It takes 45 minutes on a fairly okay machine. You need to have all the accounts, the IP addresses, the networks, all that ready, because once you start the script, it's going to run for 15 minutes, and then it says, please enter the IP address of your VMware host. Okay. And then you find that, you type it in, and 10 minutes later, it's going to go like, can you please enter your credentials for. Isn't the script like, you add everything in the beginning, right? And then the script, no, that's not the way this works. It keeps on nagging you for 45 minutes about different questions, because there are all different scripts that does different things. This is preview. This will change. I believe that it will be more of a select, and then it says, on what local VMware environment would you like to run this? This. Okay. And then it will do everything else. I think that's the goal. That's what they are aiming for. But it's going to take a while to do that. Do we have any customers running this? Besides us, because it's pretty obvious that we use this, we do have a couple of customers that are right now testing it. And the reason why they want to do this is because they realize that it is a dumb idea to have everybody poking around in the VMware environment. Nobody should be there. If you have a VMware environment, let's say that you have a company, you have 1,000 servers. How many people should have access to VMware? 1,000 servers. How many people should be able to log on to the VMware environment? 2. Those are the guys that change hardware. Everything else should be self-service. I'm pretty sure that there is not going to be enough people working on any IT department that knows enough about VMware to not destroy it or do misconfiguration. Shouldn't be there. Same goes for Hyper-V. We've seen large environments. Self-service is the only way to make these systems safe and secure, because the management interface should be disconnected from all the networks. You should not be able to ping an ESXi host. That should be impossible unless you are on the VMware network, which should be completely isolated. Anybody heard about Lockbit 3.0? It's a specialized ransomware software that specializes on attacking VMware hosts. It takes less than a minute to destroy one of them, and this destroys all the data immediately. And there's no way to recover it. And the only thing they need to do is to be able to ping 443. So if the threat actor can do that and your VMware environment isn't fully patched, then it's game over in less than an hour. How do I know that? That's what I work with on a daily basis. So if you are going to make sure that on-prem virtualization platforms are safe, they need to be completely isolated. If they're completely isolated, we need to figure out a way to allow self-service. And this is one way to enable self-service. Now, nobody needs to log on to the VMware or Hyper-V environment. You can do that through Azure. So the developer can build their stuff, IT pros can build their stuff, and people can remotely manage all this stuff without having access to the control plane and the management IP network addresses, which is the big problem. Does it make sense? Does it sound stupid? Are you going to run home and install this immediately? If you do have on-prem, then you should consider this as fast as possible. Because this is going to be, I'm not saying it's a game changer, but self-service is more than just allowing people to be able to build their own stuff. It is the only way to protect the hypervisors that you run on-prem. There is no other way, because they need to be completely disconnected from everything. Meaning that single sign-on with Active Directory is by far the dumbest thing anyone can do. I'm using a domain admin account and I can log on to a VMware environment and I'm a vSphere admin as well. That's great. Any questions? No questions?
I have one.
Yes.
This tunnel, or what you should call it, which coming through from the bridge down to the environment, how safe is that and how does it work?
So how does this tunnel work? Is it safe? The tunnel can be either a public endpoint or it could be a private endpoint. So depending on who you are and what kind of Azure environment you have. Let's say that you do have an Azure environment that includes VPN or an express route. In that case, you create internal private endpoints, and all this is connecting to private endpoints at all the times. Is the tunnel secure? It's a SSL tunnel, like any encrypted tunnel. We don't control the keys because we don't have the keys. It's a communication between the Azure Arc Bridge Kubernetes system and Azure itself. So it is the same communication. That was a very good question. Any other good? Yes?
You mentioned Azure Stack quite a lot. Do you have any customers running Azure Stack?
So the question is, do we have any customer running Azure Stack? Most of the customers that we have today that runs existing supported systems run that until they fall out of support. And when they do, they change to Azure Stack. So new customers get Azure Stack and older customers run it until end of support, which kind of makes sense. There's no point of, changing it just because you can. The benefit of running Azure Stack, it's a bit more expensive. At the same time, it's cheaper because it's the same licensing model that you have in Azure. You pay as a subscription, which means that you pay like $10 per core a month. It's not extremely expensive. It's more expensive than the previous license model, but on the other hand, there's a transformation. Anyone with software assurance can flip with no cost. And that's what the customers are doing. They already have software assurance licenses for whatever they have, and they just continue using that and change into Azure Stack. There's only a couple of customers that haven't done it. That's because they dress differently in green-ish, meaning that they have organizations that they need to run on-prem. It doesn't matter what it is. So they keep on running either VMware or Hyper-V traditionally, but they don't really need self-service either because these systems are contained for various things. But it's a good question. Any other good question? Yes?
This temp folder that's created during the installation that you want to keep track of, what kind of security controls do you want to make sure that those keys inside there stay safe.
So how do you make sure, how do you protect your installation folder that actually contains the keys? You can zip it if you want to, and open it up with a password, but it's just basic permission. Nobody should be able to log on to your machine. If that's the case, then it's bad. So, you shouldn't do it on a shared machine. You can do it on a privileged access workstation, or you build a VM to just do this and then you keep it. It's more of the make sure that you save it. But anyone with access to that folder have access to the Azure Arc Bridge Kubernetes VM. It doesn't mean they can do anything. They can do the Azure CLI command lines that we have. I'm going to go back here and just give you a glimpse of this. That's the log keys that we have. Those are the ones that we need to save. But in general, I can do this, and you can see I didn't need to authenticate at all here. I just run AC Arc appliance logs SCVMM, specify the IP address of my VMM server, and then it extracts all the log files from that. But I can do disconnect, reinstall. There's a bunch of things you can do, right? So even if it's not super dangerous, it's more important that you keep them. Otherwise, you can never connect to the machine ever. But it shouldn't be possible for other people to access it either. So don't put it on a file server with authenticated users read. That's kind of bad. That's good. Is it a good answer? Okay, thank you. Any more questions? No! In that case, thank you so much for listening to this session.